Hi everyone, welcome to this new tutorial. Today we will be building a Pokemon game in JavaScript with a p5.js library. Without waiting much further, let's look at the actual product we're going to build, actual game. So here we have a menu where you can press enter and then start the game with a camera that follows the player and collisions. You also have a debug mode that you can use to look at the various collisions and also an FPS counter at the top. Now, once you move, you can collide with a character that talks to you and wants to battle. And then you have the actual battle, and you have the various Pokemons. And then you can choose your attacks. I'm gonna choose Hydro Pump, and then Blastoise take some damage, and then again I use Tackle though, and then I I failed. So I fainted, you lost, and that's basically the prototype. So to do this, we're gonna use the p5.js library, and p5.js is a graphics library usually used for creative coding, and it's not really for making games per se. So there's a lot of logic that we are going to have to build ourselves. So we're going to implement our own collision system, camera system, animation system, and drawing the map also system. So a bunch of stuff that we're going to have to hand roll, and it's going to be a great opportunity for you to learn how game programming works on the lower level. And a lot of the knowledge that I'm teaching you here is applicable to other uh, game frameworks, I guess, like Pixie.js or ArrayLib or stuff like that, where it's really a low level way of making games. So let's jump right into it. I have set up a couple of things already. So I have 3 folders: entities, maps, scenes, and I have a fourth one which contains the assets. The assets are going to be in the description so you can get them and follow the same structure, so create all those folders, etc. We need also a main.js file and a p5.main.js file, which is the p5 library. This also should be on the description. And then the entry point, the index.html. Now let's look at the index.html. Nothing fancy, it's just the normal HTML boilerplate here. What's interesting here is that we have some styling here that is very important. This is going to be used to make our canvas responsive. So regardless of the size of our screen, the canvas should be able to retain its aspect ratio. So here is an example and that's really important, so that it can be played at any screen, basically, on any computer. All right, so I'm going to go over how this code works. So we have the body tag rule here, rule set. Here we specify that the height of the body is going to be 100 of the view height. So that means the full view height. We set the margins to 0, so there is no gap between the canvas and the rest of the page. So if you were to not use this rule, the margin would take some space here, and there would be a gap on the left and right corners of the canvas between the here. I will also set the body element as a flex container, which will allow us to use this rule to easily center the canvas by using justify content center. It centers the child of a flex container. Since it's the flex container is the body tag and the canvas element is going to be our child tag, that means it's going to center the canvas. And this logic here is just to add a background image so that it's not empty white or black bars. I thought it would be nicer to have a background that makes sense, like a Pokemon background, a Pokemon themed background. The image is, of course, in the assets as well. And then finally, for the canvas tag, we have 2 rules that are important. The max width 100%. That means that the width of the canvas cannot be more than 100% of the body width. The width available from the body has a width, and we cannot never exceed that width. And object fit contain makes it so that the canvas, when scaled, will never lose its aspect ratio. Now here we have the canvas element. We give it an ID of game here. It's going to be important because p5.js by default will create a canvas for you, but you can specify an existing canvas to not do that. And that's what we're going to use the ID for. It's to get this canvas and tell p5 to use this instead of creating a new one. Because when it creates a new one, it wraps it into a main tag. It creates also a main tag that it wraps it into, and it's going to make the responsive code tedious to deal with. Here we import the library p5 as a script tag, p5.min.js, and then right below we have a small script here that prevents itch.io scrolling. What does that mean? So if you were to deploy this game on itch.io, it's usually played within an iframe or something like that, an embed. And because of that, when you will be using the arrow keys, arrow up and arrow down, and the space key, what will happen is that the game will, the web page that contains the game will scroll down, so you will never be able to play properly without this annoyance. So this script allows you to get over this by adding an event listener called keyDown and making sure that when this event fires, so the player has a key down, it's going to check if the key being pressed is either arrow up, arrow down, or the space key. And if it's the case, we're going to prevent the default behavior, because the default behavior is to scroll down and up the page, and we don't want that. Finally, we have a script tag here that is the entry point of our game. It's going to be called main.js. It's here, and it's going to be of the type module. We want the type module here so that we can use the import syntax. So import x from y, for example. It's going to make our code much more convenient, much more well organized, as opposed to having to import script tags after script tags and adding them in this file, which is going to become messy very quickly. All right, so in main.js, let's write our first code to set up the canvas. So what I'm going to do is create a new p5 instance. The way to do this is you can use the p5 function here, the constructor, which takes in a function within and pass to it as the param a context, the context of the p5. So I've decided to name this p, but you could have named it context or any name. But what's important with this is that it's through this param, our object, that we have access to all p5 methods. So the methods we're going to need here is the preload method that we're going to redefine here in this constructor. We also need the I think it's the setup method. And then we also have the draw method, p.draw. And then finally, we actually have two other it's not called onKeyPress. I don't remember the name. It's called keyPressed. And the other one is called p.key released. So for key pressed, it comes inside with a key event that we can use to know which key was pressed, and same thing for the key released, but we don't really need it. We just want to check when any key was released. This is going to come in handy later. I'm going to add some more explanations. Now what we're going to do is, let's first start by showing you how it works to use those functions. So as a first task, let's load a font. So the way you do this is first you create a variable that you want to keep the reference of the font. This will allow you to use that font in various different methods. So in the preload method, we're going to load the font, and then in the setup function, we're going to set it as our font that we're going to use. That's why we need to have the variable outside here. So font equal p.load font, and then you pass in the path for that font. So assets dot what's the name of the font? So if you go to the assets folder, power-clear.ttf, power-clear.ttf, and then in the setup, we specify that, hey, the font we want to use, actually, I realized we first need to create our canvas, actually set up the canvas. So let's do that in the setup, and then we're gonna set it as our font. So first of all, let's create a canvas reference, so canvas element. let's use the p5 create canvas. We want a canvas of a width of 512 by 384, but we don't want to create a new canvas element. We want to use the existing one in our HTML markup. That way. So by default, this create canvas takes 2 params, but because we want to use the existing canvas, I can just do document dot create not create get element by ID, and then specify game, which was the ID of our canvas that we specified here. All right, if I go back now, there's a couple of other things I need to do. The first one is to increase the pixel density. So the pixel density is basically how many pixels are used to draw a single image, and it can vary from monitor to monitor. The higher the pixel density is, the more sharper the image will look, but the more resources it's going to consume. So usually you don't have to set it yourself manually, but on my end, on my computer, the game looks much nicer with a pixel density of 3 and above. So really it's up to you. Test it out without and with and see how sharp the image is and if it changes anything. Look specifically at the text though. The text is where, because we're using a TTF font and not a normal pixel art, it's different. The pixel art scales relatively well, but for the font, there is a little blurriness to it that can be reduced and removed completely with the pixel density by setting the pixel density yourself. Now, if you're on a smaller screen, this might not actually be needed. Okay, so canvas element, I need the reference to basically reset the styling to 0 because p5 adds some inline style to the canvas that interferes with our responsiveness CSS here, and we don't want that. So that's why I removed it by using this. Finally, as I said earlier on, we're gonna set our font to being the font we just preloaded, and this is how you do it. You call the p5 text font method, and also that's basically it. So what I'm gonna do now is I'm gonna create a menu, the menu scene, and as in the demo, you could see the Blastoise. Let's refresh. You could see a press enter fading in and out. We want to recreate this, so let's do that. So the way I'm gonna go about this, I'm gonna go to scenes. I'm gonna create a menu.js file, and then I'm gonna export a function I'm gonna call make menu. Pass in the context p. It returns an object, and in JavaScript you can have objects that have functions within. So that way those are like methods that we can use, and they can have access to properties outside of them by using the this keyword. So it's a really handy way to have a state encapsulated without using classes or the verboseness of the class syntax. But if you want to use classes, feel free to go ahead. However, if you're mostly a beginner, I would recommend just following along like I'm doing it. So what I'm going to do is I'm just going to copy and paste the properties I'm going to use, and I'm going to explain them. So here we have the start screen image ref, which refers to the actual image with Blastoise on it. And it's a reference because, as I said, we load the image from the preload function. I'm going to call it just load in this object, but I'm going to use it in the preload function here. And the same thing here, so we need a reference to both of them. Easing 0.5 alpha X and blink back is to create this fade in and fade out effect. It's going to become much more clear in an instant when we're going to actually write the logic for it. So for now, let's write the logic for our load method. So like I said, in JavaScript, you can just do this. This is just a shorthand for that. You might be more used to this. So put it back. So here, by using this keyword, you have access to the properties outside of the function within the same object. So that's really handy. And we load the image title.png from the start screen image ref, and then start.png for the start text. So those are the name of the files. Load image, load image. All right. So load image is the function provided by p5 to load images. like the title suggests, like the name suggests. All right, now what comes next is the update function. This function is, I'm gonna optimize this better. So instead of having a else statement, I can just, it's not really optimizing, it's just having a more, getting rid of the useless if statement. So what is this? So this.alpha is going to be used to change the opacity of the start text that you saw in the menu that blinks back. This one. So this is an image actually. It's not real text. So we vary the alpha between 0 to 255, which is basically the opacity. And what happens here in this if statement is that if the alpha is currently inferior or equal to 0 when the update runs, because remember, in game programming, the draw function runs every frame. So if you have your game running at 60 frames per second, it's going to run mostly 60 times. So here we have the update function that we're going to call within the draw function, because p5.js does not have a separate update functions like some other game making libraries. That's why we're going to just call it within. And yep. And here the logic is that if the alpha is inferior or equal to 0, that means the opacity is 0. That means we need to, the text has fully faded out. That means we need to blink back. So bring it back to being visible. So that's why we set it to true. If on the contrary, the alpha is superior or equal to 255, that means the text image, the start text, is fully visible. That means we don't need to blink back, but quite the contrary. And this if statement will only add to the alpha value, so make the image more and more visible, if blink back is true. That means we need to fade it in instead of fading out. And the way we achieve this is by adding a value 0.7. This is an arbitrary value. You could have decided whatever you felt good. We multiply this by the easing, which is a value that is also arbitrary of 0.5, which just will delay the fading. So it's going to give us a smooth transition, really gradually like that. And finally, we need to multiply by p.delta time. So delta time is the time elapsed between the previous frame and the frame before it, and it's used. It's offered by p5 here, but in other game making libraries, usually if you're using the HTML Canvas API, you will have to. I think you can get it for free, like from the API, from the request animation frame function, but otherwise you have to calculate it yourself, I think, maybe not. But anyway, the reason we're multiplying by delta time is to make our game frame rate independent. So the way this works is that by default, if you were to not change, not add this, not multiply by p.delta time, what will happen is that if your game runs at 30 frames per second versus 60 frames per second, the movement, so for example, let's say I want to move a character from left to right. If I add at every frame, so every time update runs is basically every frame in p5.js, that means that if I only run 30 times per second, I will be far less ahead than someone running the game at 60 frames per second, who is going to be far above me in position. And we don't want that. We want basically that even if you run your game at 30 or 60 FPS, you end up at the same position. You end up at the same position when you finish pressing the arrow key, for example. When you stop pressing the arrow key in the example of moving a player to the left or the right. And to achieve something like that, we multiply by delta time, which allows us to do that. So delta time is the time elapsed between the previous frame and the frame before it. And it allows us to make our game frame independent. There is a video that goes more into depth regarding this on YouTube. It's called Delta Time, I think. It's by Jonas Tyroller. Google the YouTube, search on YouTube Jonas Tyroller Delta Time, and then you're gonna get a much more in-depth video on the topic. Even though he's using Unity, I think it's still, this knowledge is really universal. So a lot of the knowledge we're gonna learn by making a game using p5.js is really universal, because it's so low level in a sense that it's basically can be with any graphics library. You can make the game basically the same way. The only things that change is the graphics API. All right, the last thing we need is the draw function. And here again, I'm just going to copy and paste the code I have and go over it and explain it. So what do I have here? So p.clear, so the clear method, what it does, it basically removes everything that was drawn previously. So yeah, this is important because if you draw something on the screen and, for example, you have a ball, you want to move it from left to right. If you were not to use something like clear, the ball would leave a trail as it would move from left to right, because you wouldn't remove the previous drawing of the previous frame. So by using clear, you're making sure that the text or the position, etc., is removed. And this is very important because we have a text that fade in and fade out. If we were to leave the previous frame, then we wouldn't have this effect. Now, p.image, so the image method, there's two forms of it, but the form I'm going to use right now is just to draw the background image. So you have a reference as the first param to the image you want to draw, and then x and y coordinates on the canvas you specify. Then p.tint, so the tint method here, what it does is allows us to change the tint of the image, so the colors, etc. But we are only interested in the opacity. That's why I set this to 255, and then we don't care about the first one. It's really the alpha, the opacity, that interests us. So this, by gradually moving from 0 to 255, will change the opacity of the image that comes after it, of anything that comes after it. However, to prevent the tint to affect all the other things we're going to draw later on, we need to use the no tint method, so that it really will sandwich the instruction between this and to really affect only the image, basically. And this is the start text. It's x0 and y320, because this is what looks nice. All right, so now let's go to main. And here in main, let's simply go right above here, const menu, and then call the make menu method, pass in the context p. Here .js is very important. Okay, so once we have that .js, etc., that's good. We have access to the menu object, and then in the preload, we're just gonna call menu.load. It's gonna load all the assets we need. And then in the setup, actually it's not in the setup that we need this. Oh, maybe for this specific scene, the menu scene, we don't need a setup function, but for other scenes we're gonna need that. So later on we're gonna run some code here specific to certain scenes. And then here in the draw function, for now, let's start organizing our scenes, basically. So I'm gonna create a const scenes, which is going to contain the name of the various scenes we're going to have in our game. We have three scenes: the menu scene, the world scene, and then the battle scene. So here I'm going to also create a function. I'm going to call it set scene, and you pass in a name. And if the scene, actually we could do the contrary. If the scenes doesn't include, so you use the includes JavaScript, the name, then you return early. Otherwise, you can simply set the current scene. So let's have another variable here. Let current scene equal to, by default, the menu. we start at the menu scene. So if the current scene is equal to, okay, so yeah, basically, sorry. So if the set scene is called, we pass in a name. If the name is not included in the scene, then we return early. Otherwise, the current scene is going to be equal to the name we've passed. Now in the draw function, let's have a switch statement. And then let's put in the current scene. And then if the current scene is the menu, we're going to call menu.update. And then menu.draw. Like I explained earlier on, because p5.js does not have an update method separate, we need to call the update method that we create ourselves for our scenes within the draw function. And then we break. It's important to break, otherwise it's going to go this case and then it's going to go immediately to the next case. And then here for the world scene, we haven't done the logic for it, so let's add a comment called to do break. Finally, case battle to do, and then break. And then the default is required in Kaboom, not Kaboom, JavaScript. And then yeah, so you don't have to specify a default case, but you have to add this. We don't need a default case. Okay, so we have everything we need here, depending on the current scene, etc. And then here in the key press, if key event dot key is equal to the enter key, and the current scene is equal to the menu, that means we will set the scene to the world scene so that the player can move on to the next scene. And then in the next scene, we're going to have this logic drawn instead of this one. And this is how we have a basic scene system. All right, I think we have everything needed here. Let's try it out. So I'm going to click on the Go Live button. By the way, I'm using VS Code. I'm using the live server extension. I should have mentioned this. Live server is here. Live server. Install this extension. It allows you to really create a server, a local server, very quickly. And you need a local server to run your game, basically. So if I click on Go Live here, it's gonna, if you have this extension, the button will appear here, and then we have our game. Now you might notice something strange here. So we have our canvas, it's displayed nicely, it's responsive, but the pixel art is very blurry. That's because we need to specify to p5.js that we don't want it to smooth the canvas. So we need to specify a no smooth, use the no smooth function. And now if I look back at the result, you're going to see that the pixel art is really sharp. And then if you press enter, it's going to just freeze because we stop running the update and draw functions of the world scene because we're going to move to the menu scene. So let's create our menu scene. It's the contrary. So we were in the menu scene and now it's time to move on to the world scene. So world.js is the file we're going to create. We're going to follow the exact same pattern of export function make world p, passing the context, and then the set scene function as well, because when the player is going to collide with the gentleman and then have a dialogue and then battle, we need to switch to the battle scene. And we can do it from this scene instead. Now for the various things we're going to need in this scene, there are many properties. For now, let's not focus on the properties themselves. Let's just instead focus on the methods, because we're gonna just immediately, actually, you know what? Let's leave this empty for now and let's write the logic for the entities. So the player. So we're gonna put that player inside the scene and after writing the code for the player. And once we have that done, we can basically work on the map. We're going to use tiled to draw the map. It's a handy software tool to draw maps with visually, graphically editor, rather than doing it through code, which is really tedious. But we need to then, we have a JSON export that we use and then write the code for it to be displayed on in our game. So the entities folder, we are gonna need 3 files: player.js for the code specific to the player, npc.js for the code that is going to be specific to the NPC, and then a character.js for the code that is going to be specific to both. So now, for the code that is specific to both, this is what we're going to tackle first. So if I go here, so here again, using the same pattern, function make character instead, passing the context. And then we have a bunch of properties. So here I'm just going to copy and paste and go over it line by line and explain everything. So let's first start with the properties. So a lot of the properties that are common to both the NPC and the character are things that actually are common to both, so and are related to animations. So we have the sprite ref. It's going to contain the reference to the sprite image, sprite sheet for both for the NPC and the character, but each is going to have their own instance of this object, and you're gonna see how I'm gonna integrate this in the player and NPC code so that it is independent. And then we have so we have the anims here. It's going to contain animation data, the current animation being selected. Initially it's null. The current frame, because we need to keep track of which frame the current animation is at. The current frame data, which will contain the coordinates from within the sprite sheet. For example, this frame is at a different coordinate than this frame, even though they are on the same image. So that's important to keep track of. And then the animation timer, it's important to keep track of this so that we can know when to display the next frame, the previous time as well, so we can know, both of these are used to know when to display the next frame. The tile width and tile height are important for knowing how to cut out the sprite sheet for the individual sprites, so to display the individual sprites. And then the width and the height here are for the hitbox. So if you look at the demo, the original code base, and I press shift, which is the debug mode that we're going to create later on, you can see that while the player is of a resolution of maybe 32 by 48, the box is a 32 by 32 square. And the width and the height here is going to be this for the hitbox. All right, now let's add the various methods we're going to need within the object that are going to be common for both the player and the NPC. So we have the first one called setAnimation or setAnim. It's for setting the animation. What it does, you give it a name of the animation you want to currently set. If it's not the current animation, it will set the animation and then reset everything else. So the current frame, the animation timer, the previous time, etc. So really starting from scratch, playing that new animation. That's why we have this if statement guarding, is to make sure that we don't accidentally replay the same animation we currently are playing. For example, if we're in the middle of an animation and we play the exact same animation, we don't want to go backwards to the first frame. Otherwise, it's going to make your game look really weird. All right. The other thing we need is for the set direction. So this set direction method determines the direction of the player. Now this, though, the direction property is not defined within here. It's going to be defined within the the character, I think. I think the character. So basically, this method isn't really used by the NPC in its current iteration. But if you were to have a more, let's say, expand the game further, you might need this, because we use the set direction to know when to play the idle version of a specific animation. For example, in the final demo here, if I move up, I need to know that the direction was up, because when I stop, I want to play the idle up animation, which is 1 frame. Same thing for idle down. So I hope that was clear. Okay, so now that we have this, okay, let's put it here. So this method really could have remain in the player.js file. I might move it back because we don't have this direction property here that is modified. So if you try to call this from, let's say you were just using make character by default without integrating it either in the NPC or the player code, then it might fail. So yeah, something I must consider. And finally, the last method for this file is going to be the, wait a minute. It's called setAnimFrame, and this is very important because the way I'm handling animations is basically you specify animations by an object. So it's an object containing a key and then another object that contains a to key, which is the from key. So the from key is here. So there's two variants. Either the anim data is only going to be a number, so a single frame, and that means we just set that frame as the frame we want, and then this frames also. So this frames, where is it? Wait a minute, we don't have this frames here, so that's something that again is mostly used by the player and NPC, so this property is not in the shared here, so I might need to put it. But basically the logic behind this is that we want to set the frame as the current frame here, the current frame, anim data, and then use that frame to just get this specific frame that is going to be drawn because it's a single one. However, the anim data can be more than a number. It can be an object with a from key, which specifies the first frame of the animation, a to key, which specifies the last frame of the animation, and a loop property key as well, that specifies whether or not we want to loop this animation. Things might not be clear right now, but in an instant when we're going to work on the player.js code where we're going to define those animations, it's going to make sense. It's taken from the Kaboom.js way of doing animations. It's really heavily inspired by it. So I wanted to, if you were familiar with Kaboom.js, you would probably recognize familiar things here. But I'm going to take the time to explain, hopefully. And yeah, by the way, before continuing, if you're enjoying the content, feel free to subscribe. It helps the channel a lot, and even leave a like and comment. So yeah, it could help really rank this tutorial high on YouTube. Okay, so now this current frame equals 0. So in the case where it's not just a number, we check if the current frame is equal to 0. That means that the animation hasn't started yet. And if that's the case, because when we reset an animation, we set the current frame to 0. So in that case, we're gonna set the first frame of the animation to be the one from. So that means we're starting a new animation. And then we have another if statement this time around, because this setAnimFrame runs every frame. So because it runs every frame, it checks at every frame whether or not we have started a new animation or we have finished an animation that is supposed to loop. This is this if statement. So if the current frame is superior to the 2, that means the last frame, and the loop key was true, that means we need to start back from the beginning. And then we get the current frame and return it. So this not only sets the anim frame, but also returns the frame data that is going to be used and then to draw it. The current frame for this is going to be set, and then this is where the interesting bit is really. So duration per frame is basically the time that you're gonna leave for every single frame. For example, I might have not explained this properly, but what I mean is that if you have a frame rate, so the speed key specify the frame rate for the animation. So let's say we have an FPS of 2. That means that for every frame, because it's a FPS, it's the number of frames per second, that means we want to figure out how many time is allocated to each frame, for how many time we're going to display that specific frame. So if we have 2 frames to display in 1 second, that means an FPS of 2, we divide 1000 milliseconds, which is basically 1 second, by the speed. And this is if we have 2 frames, that means we have 500 milliseconds per frame. And this is where the animation timer comes in handy, is that if the animation timer is superior to the duration per frame, that means we have displayed a frame for 500 milliseconds in the case of 2 FPS already. That means it's time to move on to the next frame by appending the current frame, plus plus, and we set back the animation timer by reducing the duration per frame. By the duration per frame. This is instead of putting it back to 0, because in some case you can have I saw on the internet that it would delay as time passes on. It could have a desync issue where a frame rate is not displayed for that much time and for the 500 millisecond time. And as time would pass on, for example, for 2 frames, instead of having 500 milliseconds per frame, for those 2 frames, it would be like 499, etc. And it could desync if you were to set back to 0 instead of just subtracting by the actual duration per frame. So this is just a safety measure. All right, yep, that's all the logic for this. And now we're gonna do in the next part, the player.js code for it, and hopefully things are gonna become more clear. Before moving on, I would just like to say that it's normal if you don't understand everything here, because it's not straightforward until you see actually how it is being used. Just one thing also I wanted to add is that instead of having you had a set direction. Here we don't have a direction property, so let's just add it here instead of in the player, even though this property is only used by the player, but just to have a more general code in case you want the NPC to have more complex behavior, because for now the NPC is just going to stand there and talk to the player and do nothing else basically. So, but if in the future you want to expand on the game, then it's a good idea. So let's set it up to null initially, and then when you will call the set direction, you will set it to a specific direction. All right, so in player.js, this is where things are going to make hopefully a bit more sense. So in there, I'm going to write export function make player, and then close the function. And as always, it's the same pattern that is repeated. Not page event transition, sorry. It's the same pattern that is being repeated. And then here, this is where things get interesting, is that we're going to spread the make character call. So here we call the make character function that we wrote in character.js. We need to both have the p tag here as well. P tag here, and also we probably need also X and Y, which are the positions we're gonna need. Okay, so what I did here though, and you have to import it. So does it suggest to import anything? No. All right, let's import it manually then. Import make character from character. Don't forget the .js at the end. This is very important. As I explained earlier on, if you don't do this, you'll get a MIME type error. And then here we spread the result of a call to make character. So character.js will give us, when we call the make character, an object with a bunch of properties and methods. And by using the spread operator, we're basically taking all those properties and using them in and spreading them in this object. So we can have direct access to all those methods because they are basically included as if it were directly inlined and put in the, for example, here, as if you had the direction property here. So that's spreading. This is what it does in JavaScript. So yeah. Then below, we're going to write our specific things, specific logic. Now, I noticed that X and Y could have probably gone here. So we could have X and Y here instead and specify it. But you know what, it's not important. So I'm going to first create a first property specific to the player. It's called the speed because the player is going to be able to move. And let's put a speed of 200 pixels per second. And then X and Y is coming from the params. X and Y's are coming from the params. Then here again, I'm going to create something called screen X, which is something, it's a property that's going to be used by the camera, because at one point when we were going to implement our camera system, all characters or all objects in our canvas are going to be relative to the camera. So I'm using this different property to know where to place the player, the actual player on the screen, or relative to the camera. So for now, when initializing the value, it's just the same as the coordinates that you want to put the camera, the player in. This is going to make more sense later on. So here, then sprite X and sprite Y are two properties that are going to be used to determine where to draw the player, the actual sprite of the player. Because for now, if I go back to the demo and go to the original code base, and then I press shift, so I implemented a debug mode, so the actual position of the character is actually at the top left corner of the square here, the hitbox. But the sprite itself is at a different value. So the coordinate is relative to that, and it's going to be 0 as well for the x-axis, but minus 15. So it's going to put the sprite a bit above the hitbox. And that's how it gives you this cool effect that when you go to this wall, then it doesn't look jarring, because if you were to have the sprite exactly drawn at the same position as the hitbox, then you would stop here. It doesn't look weird, but in certain cases here, you could like stop here and not being able to move. And this is more like the cap going a bit above gives a depth effect. So yeah. Okay, so we have the sprite position. This is going to be used later. And then finally we have the freeze boolean set to false. This is to prevent the player movement when the player is in a dialog. So I'm going to use this boolean later on to set things up like that to prevent the movement of the player, basically. Now whoops, what is this? I mistyped something. So let's have the load function. So the methods we're going to need in this object for the player is load prepare anims, and then the other one, we have prepare anims, we have move player, so the logic to actually have the player move. We are also going to need, so we have the player move here. We're gonna need a draw function, of course, a setup, an update, and a draw function. So setup, things that are going to be ran once initially, for example, setting the direction of the player. I think we're gonna do it here. And then we have the draw function, which is the update and the draw function, which runs every frame. And then don't forget your commas here. So if you don't have the comma, it's gonna give you an error. And then finally, yeah, those are the methods we need. So let's start with the load. So we need to load our sprite sheet. And the way we're going to do that is by simply calling, by using this .sprite ref, which this property is defined within the make character and is spread inside of this object. That means we'll have access to the property sprite ref. And then we have p.load image coming from p5. And then finally, the path for this, it's going to be assets dash boy run dot png. Now you could technically do this instead, like relative. I think I've established this as the pattern. So yeah, a relative path instead of an absolute path. It doesn't matter, really. Both should work. So feel free to choose one. Okay, now we have this done, which is a single line. Here is the prepare anims function, this is very important, and it will basically allow you to understand how the animation system works. So first of all, we need to have this dot frames. So this again is a property I've added here. Is it here or I didn't add it here. Let me see. This dot frames. Okay, well, it seems that I forgot to define it. It doesn't matter because if it doesn't exist, we will just create it. But I prefer having my attributes defined first. So it's an empty array for now. It's going to contain the frame data for each. So the frame data is basically the x and y coordinates of every frame. This, how we get this, we're going to have to write some logic to go over the sprite sheet here and iterate through that to the dimensions and slice it in a certain way so we can know every frame where it is. But before doing that, let's leave it, let's comment it out, and let's just set up our animations so you can understand the thing I talked about earlier with this, not this, with from and to, etc. So here again, I'm just going to copy and paste it and then go over it. So this is how I defined the animations. So it's basically an object, and then again here are the anims. If I go to character, I think I have it here. So it contains the animation data in the sense that which frame from which is an animation. So it's a key. So it's an object with multiple keys, and those keys, for example, idle down is just the frame 0. Idle side is the frame 6, idle up is a frame 12, and then this is where it gets interesting. Run down is from zeros, from the 0th frame, because frames are going to be counted from 0 to, instead of 1, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in that case, that's why it's 0 to 3. That means it's 0, 1, 2, and 3, the first line, basically. And then loop, we want this to loop. And the speed is 8 frames per second. You can play with those values once we're going to have everything set up. So this is how I defined animations. And here now, this should make much more sense why I'm taking to, loop, from, etc. That might not have made sense initially. So it's coming from there. It's coming from this, which is defined this.anims. All right. So let's write the logic to get the specific frame data. We're going to write this in a separate file because it's useful not only for the characters, but for any sprite sheet. So that's why I'm going to create a new file at the root of the project. I'm going to call it utils.js. So utils.js, here it is. And then in there, let me just look it up. I'm going to call it, so actually we aren't really, we aren't going to the image and actually going through the image itself. We're just having the dimensions. So the way we're going to proceed here is we're going to export. So we're going to create a function that we're going to export later on. I'm going to call it get frames positions because we really want the positions of every frame. So get frames pos, I think that's a good name. There could be a better name. And the param we're going to need though is number of columns. So nb calls, I'm going to call it nb rows, and then tile width and tile height. Okay, once we have this, let's fill in the body of the function. We need to specify how many columns and rows there are in the image you want to process and the tile width and tile height of each tiles so that we can know how to cut it out, how to find the various positions of each frames. So actually this code, this function doesn't need to process this image at all. It just needs to know what are the dimensions of that image. So what number of columns, number of rows, and this is manually inputted by you, the developer, for the specific case. So let's have a frames pos function, array that is going to contain an array. So this is an array of objects, And each object will contain an X position, probably Y position, I think, yeah, X position, Y position, etc. Now let's create two variables, current tile X, initially 0, so we'd start at the bottom top corner. So imagine this is on the canvas, or it's a Cartesian where the origin is 0.0, and as you go forward you have more and more pixels, so the value of X increases and the value of Y increases when it goes down. So if I go to utils back again, we have let current tile X, let current tile Y equals 0 again, and we're gonna have a for loop, let I equal 0, and then the goal here is to navigate through each, so we want to compute the coordinates of each frame. To do so, we have this for loop that starts at 0 and is going to increment until the number of rows is achieved. Here we go. And then we have the same for, we have the same for the columns. So it's going to make sense in an instant. Let me just type it out, and number columns, J++. All right, and now what we're going to do is in the frames pos array, we're going to push an object we're going to create. And this object is going to contain two coordinates, which is the coordinate of the current frame. And it's just going to be current tile X for X. And for Y, it's going to be current tile Y. But so since we're going through the columns, and for example, here there's 1, 2, 3, 4 columns, that means the way it's going to work is after having processed a column, we're just going to increase the current tile X by the tile width. By the tile, and then once we finished, so this is basically going through the column for going through a row for checking all the columns. So this is our for loop. Our first for loop starts at the first row, and then the second for loop within is going to go through all the columns for that row. So 1, 2, 3, and just actually just the first line. So for the first row, check the various columns, and then the for loop for the second row, check the various columns, etc. So after having done this, so once we complete a whole row of columns, it's time to move on to the next row. It's time to reset, the column, the X position to 0 to go back to the beginning. So, and then to also increment the Y position by the tile width, tile height, by the tile height to go to the next row. So let me just demonstrate how to run this. Let's just finish the body first, and then at the end of the day, we return the frames pos. So for those who didn't understand, we start here, first row, we go through the first frame, we take its coordinate, second frame, we take its coordinate, third frame, we take its coordinate, fourth frame, we take its coordinate. Once this is done, our X is some value superior to 0, but then we're going to have to put it back to 0 and increase the value of Y to go to the next row, and then do the same thing, and then go back here, drop down, etc. Hope this was clear. Now that we have this, we can go back to the player, not the NPC. Where's the player.js? And in here, we're gonna get the various frame positions. So this, I think a better name should have been this.frames position, but yeah, let's keep it that way just to not mess up the rest of the tutorial. But yeah, sometimes I make decisions and then I realize it should have been a better way. There could have been a better naming for this, but it's too late. All right, so here, if I go back to the player, I'm gonna call the get frame pause. Now make sure to import it. So it doesn't matter the order. If you want to import if you want to use the convention that every first entities, things that deals with entities, and then utils and stuff like that are imported last, can do it like that. All right. Now, so the number of columns here, so this is for the specific image, and I think, yeah, we manually enter this, but however, yeah, so we manually enter this. So it's going to be 4, 4, 4, and then for the tile width and tile height, we specified it in the character here as 32 by 48 because both the NPC, where's the NPC, the trainer gentleman? Yeah, both the NPC and the player have the same dimensions. Now, I think that maybe you should have just, could have just gone, let me just find the file. Maybe we should manually specify here, but I don't remember if I use the tile width and tile height later on. So let's just use it as is and not modify it because it seems a bit too hard-coded. Could have decided to not have this hard-coded and just for the specific entity, just enter 32 by 48. But let's keep it for this. Let's keep it for now, just in case I use this later on and it's gonna mess up something. Anyway, so tile width here. This tile height, and here we go. We have our frames and the anims decided. Now let's go to the logic for moving our player. And the logic for moving our player is going to be relatively straightforward. We want to have a param here where we specify by how much we want the player to move. So in the move player, let's have an if statement, actually 4 if statements. Could have, yeah, I think we could, we're better off having, thinking maybe a switch case, but I don't know if it's actually going to work because the way we're going to determine if the player is pressing a key here is we're going to use the key is down. So while the key is down, we do p dot right. So this is something coming for p5, right arrow. Right arrow. And then if this is true, or this dot, actually not, never mind. We don't need this. So if the key, what we're gonna do is simply the following. We're going to have the direction, set the direction to being right, because we're gonna move right. Set the animation to being the side animation. So this side animation is for both left and right. Later on, we're gonna write code to make sure to flip the player like a mirror when they want to go to either right or left instead of using the whole separate animation. Because I wanted to do it this way because it's gonna save time in future projects where you don't have to have the sprite defined for both right and left. You can just have one, so left and then flip for right. So I'm gonna just format this properly. So this direction, this set direction dot right is going to set the direction to right if it's not there already. It's not set to right. Same thing for the animation. It's gonna set it to run side if it's not already there. Otherwise, you're basically replaying the animation from the start, and we don't want that. And finally, we're gonna modify the x value by adding it the move by to make the actual player move on the x-axis. So for the rest of the code, it's the same thing. So I'm just going to copy and paste it and show it to you. There's nothing different, just a different value here. So I think we can refactor this into a switch case. Let's try it out. So if I have a switch, and then p dot, I don't think we can because this requires a param. requires to give it the key, you won't actually look for it. And if it gave you all the key being down, then the current key being down, then that would work. I think there might be a function for this or a variable offered by P5. I'm not aware of it. I probably missed it. But yeah, so just leave it. Let's leave it like that for now. So here again, the same thing, just different animation, different directions. For the setup now, so we have this prepare anims, which is going to get the frame, each frames. So yeah, it will get each frames for our animations and also define all the available animations we want. So direction, here we set the direction to down and the initial animation to idle down. And then in the update function is where we're going to calculate the bunch of values. So I'm just going to copy and paste it as well and talk over it. I think it's going to be better. So here the previous time, we set it to the current time. And then in the animation timer, so yeah, so we have the previous time. And the reason I'm doing this previous time is to actually use the previous time anywhere else. I actually think this might not be useful at all. So you know what? Let's comment it out for now. And if things don't work, that means I added this and forgot to remove it. And that means we're gonna remove the previous timer as well. Okay, so we have the animation timer where we add the delta time. So the difference, the time elapsed between the previous frame and the one before it. And then as we do this, it gives us basically a timer, kind of a timer. And then for our animations, and as I explained earlier on, the way animations worked, we get the duration per frame, and then we see if the animation timer is superior to that value, and if yes, that means it's time to move on to the next frame, and then we subtract the duration per frame to the animation timer. Usually it's supposed to be 0, but in some cases it's like 0.5, etc. So putting 0 directly might cause issues later down the line. Here, move by, we calculate, so we use our speed, we divide it by 1,000 milliseconds, and then we multiply it by the p.delta time. This is for our frame rate to be frame rate independent, as I explained earlier on. Then we pass it to the move player function. And then here for the anim data, we set the current animation. So from this anims, so this anims is this, we just get the one we are interested in, and this is going to act as our anim data. And this is how you see that sometimes this is just 0, so a number. And that's why in character.js, here, I had the first if statement to check if the anim data is just a number. In that case, we just get the current frame and get the frame position. So this dot frames here is the position that we return. Okay, so here, and then the current frame data, which is this setAnimFrame. So the reason we set the current frame data is because in the draw function, we're going to draw the current frame. So const anim data equals this dot anims dot this current anim. So we have the current animation. It gets the specific data for it. So either this or this. Once this is here, we pass it to the setAnimFrame, which is in here. If it's just a number, it's going to return just a single object with x and y coordinates for that specific frame. Otherwise, it's going to return the current frame as well. Regardless, it's going to return the current frame. The current frame being a number, and this determines whether or not we need to move to the next frame. And once we have the current frame data from this, we are able to use this attribute and draw it here in the draw function. So let's do the draw function. So the draw function, I'm just gonna again copy and paste, but this time around I'm gonna have to remove some code for now. So as you can see here, we have a camera system that we have not yet implemented. So usually this should take a camera param, but for now let's comment it out. So let's leave it here. So the screen X is where to put the object relative to the camera, and usually it's done by using the X coordinate plus the camera X coordinate. and the same thing for y. This is how you get the camera, by having the all objects in the screen positioned relative to the camera, and then you just move the camera itself. Either you move the camera itself, and you're gonna see how we're gonna do that in an instant. I might just do that next instead, so that I can see it quickly. And then here we have something called a push and pop functions in P5. Basically, if you want something to be applied to just, so for example, you use push, and then you apply a bunch of things in P5, and then you pop it out. So yeah, and this draw tile function, I think we haven't done it yet. We haven't. I don't think we have it yet. So this is a function we're going to use to draw this any given frame from a sprite sheet. So for now, let's go over, and this is for the debug mode. So you know what? Let's remove a bunch of code. So this we're gonna keep it. Okay, you know what? Here I'm just gonna comment it out. And this is basically to, if the direction is right, we're gonna flip the player, and you flip like a mirror by using scale -1, 1, and then translating, because it scales the whole screen. And that's why we need push and pop, because you just want to apply this scaling and the mirroring to just the sprite we're going to draw using the draw tile function. That is something we're going to define, and it's not yet defined. And that's why we need, because it scales everything in the canvas at the moment. So it's going to put our sprite in a weird place. You're going to see in an instant. And that's why we need to do this calculation here, where we multiply by -2 the screen X position of the player, and then we subtract the tile width, so we can get the exact same position we had earlier on. And this was one thing that really tripped me up and took me a lot of time to figure out. All right, so let's go to the utils. Go to export function draw tile. And then for the params for this, there's many, a lot even. So I'm just gonna, okay, I'm gonna copy and paste it from my original code base and talk over it, just to not waste too much of your time. Okay, so what is this? So this is a function. We have put it in the utils.js. It takes in the context, the P5 context, to have access to the image function, which is actually the function used to draw an image on the canvas in P5. We have the source, which is basically the reference to the image. Destination X and destination Y are going to be where we want to put the final, so the sprite itself on the canvas. Source X and source Y are the coordinates within the image. And we need this because there is more than one frame within the same image. So we need to use the positioning within the image to know, hey, draw from this part, only this part, for example. And the tile width and tile height is important to know for P5, to know how to cut out and only display this part, for example. So it uses the image function like I used earlier on, but instead of taking 3 params, there's a second form of it that can take 1, 2, 3, 4, 5, 6, 7, 8, 9 params. And here it is. So basically, the source, the actual position you want to put the canvas on, the image on in the canvas, the tile width and tile height of the final resulting image that is going to be displayed, the source X, so the coordinates within the image you want to display, and the tile width and tile height here are the cutout within the image. So it's a 32 by 48 image that is going to be cut out from this this 128 by 192 big image sprite sheet. And the resulting image is going to be put with the destination X and Y on the canvas, but it's also going to have the dimension of 32 by 48. So I hope that made sense. So in P5, you have where you can place the actual image itself, the whole thing, And then from within, you can cut out the specific portion you want and put that instead. And that's why it has a longer form. All right, with the destination being the coordinates within the canvas itself, and source X and source Y are the coordinates within the image, the sprite sheet itself. This is useful for cutting out the specific frame from a bigger image, and this is useful for displaying the actual image in a specific place with a specific size as well. All right, I hope that was clear, and we can go back to the player. So we have this defined. We need to import it though, and here, draw tile, and here we go. I think we have everything we need to draw it, but we haven't placed anything, and that's going to be for the next part. I think it's best to just start implementing the camera system. So I'm going to comment, whoops, I'm gonna remove the comment I just added. Okay, let's create a new file under entities, and I'm gonna, let's consider the camera as an entity. And then here, same thing, same pattern, export function, make camera, pass in the context. I don't think we are going to need that though. Yeah, we kind of need the p5 context because we're going to use it to know the width and height of the canvas. So the properties we're going to need is x and y coordinates, which are going to be the current x and y position of the camera. So we're going to first specify this in the constructor. And then two other properties that we're going to use are the prev x and prev y. Those properties I just created are going to be useful to know what was the previous position. I think this is so we can know when to move the camera. I'm not sure if I actually ever use it. In fact, I don't think we use it. So I'm just going to remove that. So we only need the x and y coordinates and two methods. The first one is going to be, I think it's called attach to entity. And the param is going to be an entity, and it's more specifically, it's going to be the player because we want the camera to follow the player. And then this dot entity equal, and then this property is created especially when we call this function at the beginning. So I don't think we need to create a null entity here, but we could create a set1 to being null for now, just so that all of our properties that we're going to use are defined, so this doesn't come from nowhere, even though it can create the entity property here if it doesn't exist. But just for clarity's sake, let's keep it there. The other thing we're going to need is the update function. And because the camera isn't something that is drawn, what it does is basically the most important part is really the x and y coordinates. We need to have the updated x and y coordinates of the camera at all times to know where to draw the rest. And the way we figure this out, so to place the camera at the center, so to center the camera on the player, we need to do a little bit of math. And the math we're going to need for this is this dot entity dot x, so the minus x position minus actually plus p dot, so width. P dot width is a p5 variable that gives you the width of the canvas, and then divide that by 2. And then the reason we need to do minus here is because the way the camera, I think the way it is we're going to see it later. So I think for all those math formulas like this, maybe I will forget, but play with them when we were going to display the actual character on the scene. This way, I think it's best than doing a schematic or anything. It will give you a true intuition of why we need those formulas the way they are. So yeah, I'm gonna try to remember, but I might no guarantees because I might forget. Okay, so the height divided by 2 as well, and this will center the camera around the entity that is being attached to. All right, so now we have the camera system. we have everything for our player. Now what is left is the debug mode, of course, but this is gonna come a bit later. What we want is to actually have a scene. So have the scene and then place the player within that scene. So first, let's create a, okay, I already have it. So let's go to world.js. It's empty for now, but let's fill it in. So I'm first gonna create a camera property, which is going to hold the camera, and we're gonna call the make camera function. And of course, we need to put a .js here, as I've explained earlier. Now here for make camera, I'm gonna put the P as the context, and then for the initial X and Y coordinate, let's put it at 100 by 0. It doesn't really matter in the end, because once we attach the camera to the player, it actually doesn't matter. It doesn't matter at all, and you could have written the code for the camera to not accept an X and Y coordinate from the outside and just allow you to attach it only. So I think that would have been a better choice, but at the time when I was developing this game, I didn't know this, and I was just experimenting. So feel free to make better decisions here. The second property is going to be one for the player, where we want to place the player somewhere in the scene. Let's put it at the origin for now. So 0, 0 of the canvas. And of course, don't forget the .js here. Okay, let's have a load function. There's a bunch of other properties we're gonna have to add later on in the tutorial, but for now, this is enough. So let's focus on the load, the setup method, and then the update method, and finally the draw method. Update method, and finally, okay, for now let's keep it at just those two, and the let's add the draw function. The rest is gonna come later. Whoops, add the comma, don't forget that, it's very important. All right, for the load, we're going to have to load our player assets. So this .player .load that we created initially. And then for that's it, basically. I think that's it. And then for the setup, this is where I think we're going to have to attach the camera. So the way I'm going to do this is first I'm going to call the player setup. This .player .setup that we already wrote in player.js. And then now what we're going to do is have this .camera .attach to, and then pass in this .player. So attaching the camera to the player. And if you go to the camera logic, that just means that we're going to center in our update loop the camera along the entity. So the entity that is being centered on is the camera, the player, sorry. And then in the update, we definitely need to call both this .player.update, and we also need to call this .player this camera.update. All right, so once this is done, I think we're ready. The only thing left is for the draw. So it's in the world logic that we're gonna actually draw the player. I think we have already the method for that. So player.draw. And then here we pass in the camera. And actually, is it needed? I don't think so, because the update does this thing. Actually, I realize that this might not be necessary. I'm a bit confused. Okay, never mind. Okay, let's try it out this way and then we'll see. Now, back in main.js, let's here, right below the menu, set const world equal make world, world, then p tag, not p tag, the p5 context, and then in the here world.load, in the setup, we're gonna call, do we need to set up the world? Yeah, I think we need, yep. So here, right below, world.setup. And finally, in the draw function, we're gonna have world.update. Whoops. And then world.draw. So world.update and then world.draw. Once you have both of these, I think we're ready. Yep, I think we're ready. So let's look at the result. Okay, there's an error. Make world is not defined. I forgot. I forgot to import make world from world.js. Now let's look at the result. This.prepare anims is not a function. What, really? Player.js. Let me look at the code. This.prepare anim. Why it's not supposed to be prepare anims? And then the error issue is prepare anims. Oh, I made a typo error. So back in the player code, in prepare anims, add an E here. Forgot. Line 18 here. Okay, now it works. Let's go back to the console, and then I'm refreshing just for making sure, and then I hit enter, and then there's a camera is not defined. What do you mean camera is not defined? Did I pass the camera in the world? Ah, it's this.camera. This.camera. Then hit enter. And then I forgot to clear the scene, of course. So in the draw of the world, let's do a p.clear. It's gonna remove everything that was prior. So if I do this, press enter, and then we have our character, depending on the situation. Now we need to write some logic to actually make the character move, etc. Well, actually it's moving, but first there's two issues. The first one is that the canvas is transparent here. We haven't set a background, and also the camera. So there's really no way for us to know if the camera is actually working well. But at least you can see the animations. Okay, let's work on fixing that. I'm gonna set a background as well, just to have instead of a transparent color, it's going to be a very specific color. Let's put the background to being black. You can do this by using the background function from p5.js and setting it to 0. If I click enter now, it's within a black background. Now the other issue though is not only do I need to, I think I need to call the player update. Okay, we do that already. So what I need now is, it's gonna be tough, because I want to put, okay, let's put in the world, let's make a draw call to p.rect, which is a function for drawing a rectangle. Let's put it at 100 by 100, and then the width is 50 by 50. Then let's see if we can notice any difference. Okay, the player is not moving. Why is that? Alright, so I fixed the issue, and now we can have a fully functioning camera. The reason is that in the rectangle, I first put the camera. I don't think this is necessary, but I think I put the camera update before the player update to fix this. But let's try it the contrary. But really the issue was this, was the way I drew the rectangle. So how it works is the following. So I'm just making sure that it doesn't matter. Yeah, it doesn't matter which order you put the update with the camera or the player. But I'm just going to put the camera first. It makes sense to set the camera first. So here the issue is that everything that we're going to draw so far in the canvas that we want to put in a specific position must be drawn relative to the camera. So you have to do 100. For example, initially I put the rectangle in the coordinate 100 by 100. But if you do that, it won't move because it's not affected by the camera movement. So that's why you need to have to append to it the camera.x position and the camera.y position. So I think that's why it's necessary. Now for the player himself though, I think the reason we here add plus, let's try it out basically. If we try to remove it and go here, you see it's very weird because the player isn't, the camera is centered on the player, but the player position is not based relative to the camera, so the camera is acting very strange. It's not centered at all. So that's why I put the camera, I added the camera here. Now, one thing also I wanted to check on is that the scaling. So this formula is strange, but this is what happens if you, this is how we get, for example, if I go back, this is why we can get one direction and the other at the same position. If I were to, instead of multiply by -2, just do this and look at the result, you see, my character would glitch out. If instead of -2, I would just put -1, would it work? I think you see, it flips, but it flips the whole canvas basically. So that's why it's important to have this formula of -2 multiplied by this, the screen X. So that means the camera, the position after accounting the camera's current relative to the camera, basically. The position, so screen X is the position relative to the camera. Once we have this, we can basically have this logic so that our character, when they look at the right side, they will flip correctly and at the same position. So scale -1 is what flips like a mirror the sprite, and p-translate is what puts the resulting sprite at the same position, because by default the camera, not the camera, the p-scale will scale the whole canvas until you pop it. So here we only have one call to drawing the tile, the sprite itself. So that means it will be the only one affected. But as you saw initially, it's going to put the character at a different position, because it's as if you were flipping the whole image and not just the sprite, the whole canvas and not just the sprite. It's a bit hard to explain, so that's why I recommend that you just play with those values. All right, so now that we have the background here, I think we're ready to so we have a resulting, okay, yeah, let's play with the formula here. So what happens if you remove, so in the make camera, if I were to remove the p.width divided by 2, where would the camera position itself? It would position itself at the top left corner. That's why we divide by 2 to be here, and then by 2 to be here, so to be at the center. And then it might look strange because it's very weird, but that's the formula that works. So if I were to remove the negative value and see what happens, you see the camera is weird. So we need not only to put the minus symbol, and then, okay, it makes sense, because if we were to, so we could, maybe this could work as well. We take the current position of the entity and we subtract the half of the width. If I were to do that, okay, it doesn't work at all. If I were to do this again for this as well, would it work? Would it work? No, it won't. Okay, that's very strange, but that's the formula. I don't have a very good explanation for this. I stumbled upon it through trial and error, and I got it. So I was playing with values here. So for example, if I put the width and the height instead, so I add the whole width and height, and it disappears. If I were to divide it by 3 though, disappears. If I were to divide it by 2, it's down here. So the width puts the character at the, what? Makes no sense. absolutely makes no sense, but it's kind of strange. So we have the width that would put the character. Okay, so let's change just one param. So let's look at what happens if we just use the normal width. The character disappears. What if we divide it by 3 instead of 2? It puts us, it puts us to the left corner. Okay, if we were to divide it by 5, it puts us even farther at the left. So that's very strange. So that means if we were to so what happens if I just remove this and I remove this? Where would it put the camera? It would put it to the top left corner. But my question is, why normally, intuitively, you would just add to the entity half here. So what happens if I just remove this and this as well? And just really take the same position as the entity. Okay. Ah, I see. Because when in a game, when you want to move forward, the camera actually goes to the opposite direction. Otherwise, because here, if the camera were to follow the exact, it's troubling to explain it because look, the camera is currently like following the player. But what we want is for the camera to go in the opposite direction of the player. Because if we go at the opposite direction, it will make everything scroll towards us while the player is going forward. Because the player is only the only thing that is like basically stationary, while everything else is, well, actually everything is relative to the camera, but because the camera is attached to the player, we want every other object in the scene to go to the opposite direction of where the player is going. And this will give us the illusion of having a camera system where the camera follows the player, while actually it's everything else that is coming in the opposite direction. I think that's why it makes sense. Okay, I think I have a better understanding. So if we do a minus here as well, and then here, okay, now it works. And then the width, the plus p.width divided by 2, and the plus p.height divided by 2 is just so that the camera is positioned at the center of the canvas. And it makes sense because half the width is this and half the height is this, so it's gonna put the camera, the player at the center. All right, okay. Glad I truly understood now how it works, because I really found it through trial and error. I think I knew that the camera would go to the opposite direction, but I just kind of forgot because it took a lot of time to make this game, the prototype. So yeah. Now what we're going to do is, I think we have the player, we have everything. It's time to, there's one thing left as well. We need to make sure to put back the animation to being the idle version. So here, the way I did it in my original code base is to have a key released method that I somehow put here in the world.js. I put it here, key released const, it will basically take a const, so it will look through all these right arrow, left arrow, up arrow, and check if any of those keys is down, if is released, sorry. No, it's down, it is down. And if there's even one that is down, that means there's no key. We don't want to actually run the logic that checks for released keys. Now, one thing I find strange is why this is here. Why is this here? Because what I would... Okay, I think I know why. Because to have access to the released function from P5, this one, it's a top-level P5 method that is at the beginning. It's one of the main functions, and we just have to put it for that specific scene here, so call it from there. But you could argue that it might have been a better to, well, actually, main.js will never have access to the player directly. The player and it is only used through the world.js, so that it makes sense to have this function in world.js and then call it from to in main.js. So here, if I have an if statement, if current scene, so this is in main.js, is equal to world, then we will allow the what is it called? World dot key, not word, world dot key pressed function to be called. Key released, sorry, key released. All right. So now, yeah, so this is to make sure that no other keys is pressed down. That means if any other key is pressed down, that means we don't want to revert back to an idle state animation. And so that means that if in the case this is not the case, that means there is no key being pressed down, so all key are being released. So a key was released and no other key was pressed down. That means we can run this, and this is going to check the direction of the player, and depending on which direction it is, it's going to set the idle animation. So here, for both case left and right, we have the same thing, idle side. But yeah, I think this can be improved. What we could do is just this. We remove that. And that's a cool thing about switch case statements, is that if you want two cases covering the same logic, you can just have this, where it's going to go here and then move on immediately to the next. I think. Let's try it out. If I do this, yeah, the character, as you can see, stops moving as soon as we need it. So that's great. All right, so we made a lot of progress, and that's great. Now the next part of the tutorial is really about drawing the map and setting all the logic for it. Once we have a map drawn, we're gonna work on having a debug mode, and it's gonna be really useful when we're gonna tackle collisions, because we're gonna have to implement our own collision system. We're going to do a basic rectangular collisions. So it's really squares, and then checking if they're colliding, and if they're colliding, making sure they don't overlap. So that's the most basic system when it comes to collisions. So before we start drawing our map and doing everything in tiled, let's just write some logic in the player.js code. So just to fix a small issue. So if I go back to the demo that we currently have, let me refresh, and I hit enter, you can see that I can press left and right at the same time and kind of slide like this. We want to avoid this. We want to only allow the player to go into one direction at once. To do something like that, we're just going to go to the utils.js file and create a function, that is going to be used to just prevent, well, actually this function is just going to check if there is only one key being pressed. And here is the function I'm going to need. I'm going to put it maybe below here at line 39. And yeah, so is max one key down, takes the context, the p5 context, and then we have this for loop where it's going to check if any of the arrow keys, if any of the arrow keys is down. As soon as more than one is down, we set the is only one key down to, well, actually, we want to check if there is only one key down. So here, we first iterate through those keys, so our right arrow, left arrow, etc. And then, as long as there is only one key down, Boolean here is false, and there is a key being down, we can set it to true. So the next time we find a key that is being down, that means that there's already one key that is already down, and that means we can return false because there's more than one key that is being down. So we use this Boolean to just check when the first key we encounter that is down, and then when we iterate again through the other keys, we can compare and see if there were already a key that was down, and if the current key is also down, that means there is more than one key down. Now if I go back to the player.js, and here I think we're going to actually do it in the move player function. So if I go here at the top, what we're going to do is simply have an if statement that is as follows. So I'm going to paste it. Here it is. So as soon as we notice that there's more than one key being pressed down, so by using the reverse of this condition, by using the bang sign here, or that the player is in a freeze state, then we return early. So that means we don't run the logic that comes after. That means the player cannot move at all. So if I go back and look at the demo, and I hit enter. Okay, I have an error. I know why. I forgot to import from the utils the functions that I need. So here we need the is one max key down to add to our import here. Now once this is done, if I go back and look at the result, you can see that I cannot move into two separate directions at the same time. So on your side, it should behave the same. Okay, so now we are ready to just work on the map itself. So we have our camera system implemented, so that's great. And because of that, the only thing left really is for this specific scene, actually there's still plenty left. We need to have the map, we need to have the collisions, we need to have the NPC. So we will have to write the code for the NPC, and then what happens when the NPC collides with you and talks with you. And that means we need to build this whole dialog system with the dialog box. And then only then, when all of this is done, then we're ready to actually work on the battle system. And the battle system is going to be simple. I haven't taken into account everything that comes with a Pokemon battle system, like the typing, so fire beats water, etc. You can feel free to add this if you want on the existing code. But for now, it's just like a basic turn-by-turn combat where you select your attack, the NPC selects their attack, etc. So to draw maps, we're going to use this software called Tile. This is what you see on the screen. You will find a link to download it in the description. So before starting, I'm not going to assume that you have any existing knowledge on how to use this thing. But here is a map I've already made. We're going to rebuild the exact same map. I'm keeping it here as a reference so I can make sure to have the exact same map. And yep. So I don't remember actually the dimensions that I picked for this project. Tile width, tile height, but how many tiles? I don't remember. Anyway, so the first thing I want you to do after having installed Tiled, you should immediately go to the Preference tab. So Edit, Preferences, and then go to Theme, and then select a custom font. So check mark this. You see, if I have this not check marked, everything is way too small. So if you do this, you select a font and then increase the font size until everything is clearly visible. This is because if you're using Tile on big screens, by default, the text is going to be really small. So we want to avoid this. Okay, now let's create our new file. So new, and then new map. Usually if you're opening the program for the first time, you're gonna have a button in the program here instead of having to go here. But yeah, you can just follow me here. A new map. And then just keep things as they are. So we want a map size of 30 tiles by 30 tiles, and we want each tile to be 32 by 32 pixels. Keep the orientation orthogonal, the tile error format as CSV, and the render order to be right down. Right down means that it starts from the right and then goes through the full row and then goes to the next row like that, downwards like that. Okay, now click OK, and then we should have a map. And then here, there's a button to load a new tile set. Click on that. And then browse through the file to the specific asset file in the project. All right, so the project should be in this following path. Just replace this part with your file system, etc. Basically, by using the browse feature, you can just know select it. So it's the trainer tower interior.png file that is in your assets folder. And then select the title width to be 32, the title height to be 32, and then click on OK. Now here you can use the control key and the mouse wheel to zoom in and out of the view here. And the top corner here is where you create your tiles, your layers, sorry. So there are two types of layers. Actually, there's more than two types of layers, but usually the two main ones are the tile set layers, where it's just tiles that you draw in, and then the object layers. This is what we're going to use to determine the hitboxes of the map, so the collisions, and also determine where to spawn the players on the map. So if I look at my previous map, I can see that I have 1, 2, 3, 4, 5 layers, and it's from the deepest to the toppest, I guess. So let's start with the ground layer. So here you can just double click and rename the existing layer. By default, it starts with a tiled layer. And then here you can start drawing. So I'm just going to try to really copy tile for tile here. Okay, it seems that my tile set is way too big. So what I'm going to do is I'm just going to copy here, and then it doesn't matter if we have too much that comes after. We can reduce the size of the map later on. Let's start with the black tile, this one. And here it's 1, 2, 3, 4 pixel, 4 tiles here, and then 3 tiles. So 1, 2, 3, 4. 1, 2, 3, 4. Here it is. So yeah, 4 here, third position here. All right. Now how many tiles we need here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's have 9. 2, 3, 4, 5, 6, 7, 8, 9. And then we just need the other one. So I think this one. Is it this one? Yep. So we just need this one here. So the one I selected here. Okay. Now for the rest, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then here we have a closing one. Where is it? Where is it? Where is it? It's this one. I'm gonna go. But by the way, I can. Okay, I need to select it from here. Okay, so where is it? Okay, this one. Is it really that one? Yep. So right below here, one like that, and then I think it becomes straightforward how to draw it. So yeah, just the reason I'm copying is I really want the exact same map I did prior to this. So I think it was nope, it was this block. Nope, maybe yes, it's this one. Okay, like that. Looks kind of. Does it look right? I think it does. Yeah, I think it's the correct tile. And then here we want that. Does it work? Yep. And then we want the bottom part. Well, actually, wait a minute. I should have been more careful with this. I can remove the visibility. And yeah. Okay, well, let's rename this part, because if you look at the original tile set, the wall is all of this and the ground is this. So I'm going to rename this by double clicking on it. I'm going to call it walls. And then let's just do the walls layer, and then we'll do the ground later on. And then here, I think you can just select like this one. So 1, 2, 3, 4. 1, 2, 3, 4. And then here, a closing one. And then one like that. Like that. I think it's, yeah, it's exactly the same. And then here one, another one, and like that. And then here, Gonna do this. So this is pretty straightforward in terms of like it's literally the same part, but I wanted to cover this aspect of making games because doing it this way is less time expensive than doing it in the code first approach. So once this is done, I think we only have the corner left, the left corner, left wall, sorry. And then this, how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then this one like that. And then we have this or this like that. And that's basically it. I think we have the whole thing done. And then for here, we just can fill it in with a black tile. Whoops. Here we go. All right, I saved the file as world.json in my folder structure. So if I go back here, you can see the inner the content of that file. We're gonna cover this later on. So now we have the walls layer done. Let's create another tile layer. This is how we create a new layer. Is you click on that button here. It's a bit small to see, but here it is. And then here I'm gonna call it ground. And then I'm gonna drag below because it's really the layer below. And then I'm gonna pick this tile first, and I'm gonna. Does it work? Wait a minute. Wait a minute. You must do something. First put the ground layer, and then you have to select the walls layer. Otherwise, it's gonna draw what you want to draw in the grounds layer, and this is not what we want. So here, I'm gonna click and fill it in. Did I do that in the origin? Okay. And really, it's the basically you just draw it in. Oh, I made a huge mistake. I didn't realize it. It's the contrary. I was in the right layer. So here, after having drag and drop the walls on top, you need to draw this on the ground layer. Sorry if I caused any confusion. Then here we go. And then how many tiles? 1, 2, 3, and 4. 1, 2, 3, and 4. And then I can just fill it in like that. I'm gonna do it this way. And then here we'll have to select another tile though here. So we have the shaded, half shaded tile, this one. Yeah, select it. What's nice is that even if you work on two different files, and if the file you're working on is the one with they have the same tile set, you can select in one, then the selection will remain. So yeah, by just drawing on top, it's just gonna replace the tile with this one. And then we want which one we want? I think it was this one, the full shaded tile like that. And then yeah, like that. I think we have it done. Now that this is done, save of course. And let's create another layer. This time around it's going to be the decorations layer. So it's a tile layer, decorations. This is just a visual like change. This layer will not contain any useful collision data or anything like that. Oh, yeah. So I've put a TV by using the 4 tiles here. I'm then going to draw a plant. Whoops, where's the plant here? I remember having it. Oh, where is it? Wait a minute. Ah, yeah, yeah, it was hidden. So let's draw the first type of plant here. And then let's draw the next one here in the decorations layer. Okay, now this is done. Now we get to the interesting part. We're gonna use an object layer. And here it's going to be called boundaries. It's going to be the collisions, the places where we want the invisible walls to be, so that the player cannot go in that direction. Yeah. So to do something like that, it's different. You don't use tiles. What you use is you go up there where my mouse is, and you select the square tool, and then you're gonna draw boxes. So here, if I put it visible, this is how I drew it. So let's first start here. So really we don't want a player to be able to go past the wall. And we don't need to have a collision box outside here. It's not necessary, because anyway the player is going to be blocked here by this invisible square. We want the same thing here. Actually, we want the full plant. So when you create a box and you want to modify it, you click on the second button here. Actually, it's this one, the third one. And then you can click on the little arrows. So if you cannot see, here it is. The little arrows here. Once you click on that button here at the top. Okay. Now we do the other ones. So click back on the square, and then this one, and then I think this one, and then we can do it this way, and then a square here, or we could do the reverse. Here I did it this way. I drew. So if I go here, there is the selection tool here that I've selected everything, but it's not necessary in the end. As long as you just block this space, it's enough. So once we have this, we have this, we have this. We only need another one here. And I'm not sure if we should have it all the way though. Did I do it all the way? Yep. And then here, yep, all the way. So here again, I'm gonna modify it. So sorry if this is boring, but yeah, it's tedious. It's less tedious than doing it manually though. It would be really even more tedious. So now I'm going to have a square here, and then I'm going to expand. This is so that the player cannot go outside of the bound of the map. And we need a last one here. All right, so now everything is done, and whoops, I created that. Be careful not to create accidental boundaries. But here we go. We have our boundaries, and the player is not going to be able to go past this after we, of course, write the logic for it. So finally, the final layer is the spawn points layer. It's where we're going to spawn both the player and the NPC. So the player, the way it's going to work is going to use those pins, the button that is right to the right of the square, the rectangle, and then we're going to place. So here I placed the, wait a minute, I need to make it visible. So the player is here. So because sprites are drawn from the top left corner, we need to really like put it at the top left corner. We cannot really put it in the middle. And anyway, the character is going to be drawn here because anyway, sprites are drawn from the top left corner in game dev by default. When working with graphics library, things are drawn from the top left corner of their origin point. Okay, now let's give it a name to this specific spawn point so we can differentiate from this one and the one from the player. And in here at the right side of the screen, you can change the name when this is selected. I'm going to call it player. And then save. And if you see player here, that means you did this properly. And the NPC is going to be spawned here, I think. Let me look. Yep. The NPC is going to be spawned here. And here again, change the name to NPC. And this is so we can differentiate them in the code. So save everything, and I think we're ready to actually work on the logic to display this whole map and then place our players and NPC in it. Once this is done, we're going to be able to work on the collisions and then the dialogue and then hopefully the battle. And then after that, it's finished. So yeah, see you in the next part. Okay, so now it's time to write the logic for displaying our map that we built into Tiled. So in Tiled, we built the map like this. We got a world.json. We put the map in a maps folder here, and just let's look a bit at it, and then actually, you know what? Instead of doing something like that, let's start writing the code to take in this file and then generate the map. And then as we go over the code for this, you will understand the structure of the export here, the world.json that we exported. All right. So now in the entities, we're going to create a maps or map.js file. So what this file does, it's going to really generate the map from the world.json file that we used, that we made through tiled, and then display each tile. So again, here we're gonna follow the exact same pattern that I've been using up to now. So this time around, I'm gonna call it make tile the map, and it's going to take, of course, the context, the p5 context, x and y coordinate. And then once this is done, we're gonna return, of course, an object, and then a bunch of properties. So here, the first property we're gonna need is the tile width, and this is hard-coded, basically 32 by 32. If you were to use this logic in another project, you would make sure that the tile width and the tile height of each tile is passed as a param for it to be more flexible. I would then pass in the x and y coordinate of the map. So the way I'm going to design this is that we have a map object, which is what make tile the map does. It creates that object, and that object have a specific position in the canvas. What I want to do is to make sure that every tile is going to be drawn along the original x and y coordinate of the whole map, so relative to that coordinate. And then here we're gonna have a couple of methods. The first one is the load method or function that is in this object. The second one is going to be a function called prepare tiles. This is the same thing as prepare frames, I think, in the player, prepare anims that we wrote. Same logic, but this time around it's just going to contain a call to the get frames position. I've already explained this in the past, so I don't think I need to re-explain it. Feel free to jump back to listen to the explanation of that, how it works. And you can, of course, by the way, always you can go into the description and hopefully see a GitHub repo, the source code of the project that you can use to really dive into the code and read it. All right, after having prepare tiles, again, I made the same mistake. I need to add an E here. We have another method that is going to be called get spawn points. This is specific to get like the specific where we're gonna spawn the various objects. And then after that, we're gonna have a draw call that is going to take in two things. It's going to take in the camera and the player. The reason we're taking the player is so we can place it in our map. I think that's the reason. Yeah, because the way we're gonna go about this is that we're gonna create the NPC here and not as a separate entity outside. We haven't written the code for the NPC yet, so yeah, let's do that after we finish writing the code for generating the tile map, or during when we're gonna need it. So in the load function, we need two things. So this load function is basically gonna load this world.json into our JavaScript project. The way we're gonna do this is we're gonna first pass to it a first param. Actually, I don't think we need to pass in anything here. Yep, what we need, yeah, I'm gonna hard code it. So in the original code base, the way I did it was to pass this externally, and then in main.js pass the files. But you could just do it within the map.js file, because anyway, it's not used elsewhere. But you know what? Like I decided in previous decisions like this to just remain with the original code base in the end, so that if you were to follow this along using the original code base, you wouldn't see a lot of difference, and it might confuse you if you just dive into the code and then see a big difference. So yeah, I would have preferred to, in hindsight, to just write the hard code, the URL here. And yeah, so, but because I didn't do this way, let's do it the other way, which is just to have two params. The first one is the tile set URL, and the second one is the tiled map URL. So those two things, the first one corresponds to the path to the tile set, which is in the assets folder, and I think it's the trainer tower interior.png. And the second one is the tile map URL. But another thing I've noticed, I think in the world.json, maybe there's a reference to the path to the file. Yeah, you could have found the tile set from the tiled export, and you don't need to specify it from the outside. This is something I just forgot to that it existed. So yeah, I would have probably done it this way as well. Okay, now here we're gonna have a property called map. This map image, it's created, so it wasn't defined anywhere else in the object. And the reason for this is that we were just gonna use it here so you will have to call the load function before using this new property that we created. Then here I'm gonna pass in the tile set URL. So here again, p.loadImage is a p5 method, and yeah, it loads an image like the name suggests. Then I'm going to create a constant and I'm going to have a response. And this is why I used async, because we're going to have an await and then a fetch call. So like fetching an API that returns JSON, we need to fetch the URL where our world.json is, and that URL is the tiled map URL. And I'm using the fetch to get some JSON, and then it's going to give you a response. We need to use await here so that the code will not. It's because fetch is asynchronous. That means that if you call it without the await, the rest of your code will execute, but we don't want that. We want to wait until the fetch has returned the response before we can move on to what comes next. Because what comes next is we want to store into our this tiled data. It's a new property, the JSON, because the response by default is not in JSON. We need to call the JSON method on the response object, again using await, to store it. If you were to not use await here, you would have a promise. What would be stored here would be a promise and not the actual result. So a promise can be either fulfilled or pending. So it's going to be a pending promise. So when you run asynchronous code, what it returns or immediately is a promise that it's going to eventually be fulfilled. By using the await, you are waiting for that promise to fulfill and get the actual result. Now that this is done, we're ready to write the code for the other method. The other one is called prepare tiles, and then here we're going to have a tile position attribute, a new one, and I'm going to call the get frames pos that we've already defined in utils.js. Now be careful, you need to add a .js here. If you don't do that, you will not be able to, you'll have a MIME type error. Now here we have 8 columns by 55 rows, and this .tile width is 32. This .tile height is also 32. And that's it. I think that's it. Yep, that's it. Now, how did I figure this out? The 8 and 55? Well, basically I just went into my image and counted the tiles. So you can do that in tiled, or you could do it manually here. But basically, yeah. So we have, or you can do some math. You have the image resolution here. You know that each tile is 32 by 32. So if you do 256 divided by 32, it gives you 8. So this is the width. So the width, 256. It's written here below of your code editor in VS Code. Yep, you can see it here. And then you take my 1760 divided again by 32, because it's also the tile height, and you'll get 55. This is how I was able to this is how you can quickly know how many columns and rows there are in your files. Okay, Now for get spawn points, we're gonna do the same thing. So we're gonna const layer. So we are gonna have an off, a for off loop. And what we're gonna do here is tile data. So here, this function is made to be called after this has been loaded. And tile data is basically the JSON file that I've had this. Let me pull it out. Where is it? Where is it? Word. I need to find it. Sorry. Here. So this whole object, now that we have access to it, it is going to be stored into tiled data, the attribute this dot tiled data, and then here there's a bunch of properties. The properties that really we care about is the layers property, and that's why I do a const layer of this tile data dot layers. And then it's going to give us only what's in starting from this array. So we have an array that contains all of your layers, and this array contains all the properties. Okay, now that we have done something like that, we're going to have an if statement within, because we need to check if the layer type is of the tile layer or the object layer. Actually, no need for the layer type here. We want to check the name of the layer. So if the name of the layer is spawn points, then we will simply return the layer.objects. Okay, this might not be clear. Let's go over the world.json. You can see that in our array of layers, there is a bunch of different objects which represents each layer. And then for each of those objects, there is a bunch of other properties, and there's the name of that layer. So what we care about is to find the layer that is called spawn points, which, if you remember, determines where we're gonna spawn the player and the NPC. So I think it was the topmost layer. So the order is going to be the reverse, because the first is going to be what's drawn first. So the deepest layer is what's drawn first, and then we go from the top. So now spawn point is going to be the last layer here, and it has a objects attribute because it's of the object group type. There's basically two major layer types. There is the tile layer type, which will give you a data property, which is an array containing the various tile numbers for your map. And there's the second type of layer, which is the object group layer, which instead of giving you a data property, it gives you an objects property, which is an array of objects containing the various spawn points and shapes with the coordinates, the width and the height, etc. All right, now if I go back to maps.js, we are ready to write our draw function. What's in the draw function? And here we're going to need again to have const layer of this tile data dot layers. We need to iterate again through the layers. And then here, this is where we're gonna do the drawing. We first need to differentiate if we have a layer of the type tile layer or a layer of the type object group, and you do this by just checking for the type property. And then within here, I'm gonna have a current tile position equal this, which is going to be an object that is going to store the x and y coordinates of the current tile before it is drawn. So this is actually the drawing logic, how we're going to draw every tile. So here, current tile pos initially, when we first enter the for loop and after the if, it will correspond to the x and y coordinate of the map itself. And then as we draw the tiles, these two values are going to change. You're going to see in an instant. We need another variable, this time called number of tiles drawn, equal initially 0. We have 0 at this point. 0 tiles have been drawn in this row. And then for const tile number of layer.data. Now, since we know that we are in a tile layer type, we know that the data attribute exists, and because this exists, we can have the specific tile numbers. And the tile numbers corresponds to the tile numbers in your sprite sheet, and they are counted from 0. So for example, if I go back here to the sprite sheet, that means the first layer, first frame, which is a 32 by 32 pixel, is going to be number 0, number 1, number 2, number 3, number 4, number 5, number 6, number 7, etc. Number 8, number 9, number 8, number 9, etc., etc. All right. And then once we have the tile number layer data, we can have an if statement. If the number of tiles drawn is modulo, we're going to use the modulo operator to, so if the remainder of the division, so the modulo operator is the remainder of the division. So you divide by the number of tiles drawn divided by the layer width, and if the remainder, what remains, not the result, the remainder is 0, that simply means that we have drawn the full row. Because you remember, there is like in the width, you divide it by 32, so the number of tiles drawn must correspond to a number that is divisible by the layer.width. So for example, if we've drawn 8 tiles, that means we have multiplied by 32. It's going to be 256 divided by the layer.width, which is 256, I think. It's going to give you 1, the division. That means the remainder is 0 because it gives you an even number. Not even number, I mean how we say in English, an integer. So that means it's fully divisible. Okay, now once we have realized that we have finished drawing the current row, we need to set the x position, the current tile x back to 0, or not 0 actually. It should be back to the original x position of the map, and then current tile pos y though. We're gonna just add the tile this dot tile height. That means that we're gonna drop to the next row in the drawing, in the map. Okay. Now once we have done this, actually layer.width doesn't have necessarily to be 256. In our drawing, I think we had a couple of, I think max 30 tiles. So it's the layer.width is the width of your map that you've drawn and tiled, and not the width of the image, the sprite sheet, the original sprite sheet. Just wanted to clarify that. Okay. Now else, in case we don't have a remainder that is equal to 0, that means we are not finished with drawing the current row. That means we can just increment the tile pos by this dot tile width, and that's basically it. And then after having done this, we need to add the number of tiles drawn, increment that, even though we haven't drawn the tile yet. The reason for this is that we need an if statement that comes right after to check that the current tile number, if it's equal to 0, we simply want to skip the drawing. Because in tiled, if I look at the tiled export again, where is it? It's there. All right. If I look at the tile export again in a tile-based layer, you can see that the data array contains a bunch of 0. The 0 here is the absence of a tile and not the tile number 0. However, the numbering in the way when we divide the image from the sprite sheet. So when we, if I would pull this out again, if we have this sprite sheet, we divide it in such a way that the frame here is frame index 0. But in tiled, in the data array, it's actually when 0 is used, it's in reference to the absence of a tile and not a tile number 0. That's why in the rest of the map logic, After this, if we have a tile number equal 0, that means we continue on and we skip what will come next, which is going to be the drawing logic. So here we're going to make a call to draw a tile that we, again, wrote in utils because it's used everywhere. And the way we're going to draw it is by passing in the context, the p context and p5 context. We then need to pass the image source, which is the sprite sheet, the trainer tower.png, something like that. Then we need to have the position, so the x and the destination x and the destination y, which are the positions that are going to be the position of the specific tile on the canvas. And it's going to be here. We're going to have to do a bit of logic here. We're going to have to use math round and then take the current tile position.x and then add to it the camera position x, and then do the same for the math.round current tile position y plus the camera dot y. So the reason I'm doing this is I've noticed that in some browsers, in particularly Chrome-based browsers, there is a lag or a weird glitch where there is some spacing between the tiles when the tile drawing is being updated. And the way I've found to mitigate this is to round the value that results from it so that we have like integer coordinates and not 0.5 or something like that, 2.5 as an x and y coordinates. I figured that this fixes the issue mostly. However, it's still something I do not completely grasp because I'm not sure if it's an error, something that is with p5, or it's something that is in the way my code is written. So that's something that if you want to investigate, feel free to do so and leave a comment if you have found any reason why it behaves strangely on. I've tested it on Edge browser, which is now Chromium based, so maybe on actual Chrome it's normal as well. But you know, if you figure something out, feel free to reach out. All right, the next line is we want the position within the sprite sheet. As I've explained, this position, those two things here are for specific x and y coordinates within the image, the sprite sheet itself, and not what is the coordinates for the canvas. And here, by having the tile pause, and this comes from when we prepared the tiles by storing the result of frames positions, which returns an array. And as you know, in JavaScript, arrays are numbered. The elements of an array are stored with an index starting at 0 and at 1. So that's why you need to take the tile number and subtract 1 to get the actual real tile for it. Because remember, tile number 0 in the tile export, which is where the tile number is coming from, is the absence of a tile and not a specific tile number 0. That's why you need to subtract -1 here. And then once you get the tile position for that, you get the specific element, you can just take the x and y coordinate for it and draw it. I think that's and then finally you have to specify this.tile width and this.tile height, which is going to be telling p5 how to cut out the sprite sheet image for that specific frame. What did I do? I forgot a comma. All right, I think that's it for the tile layer. Now we need to continue on and do the same thing for the object group, so the walls. And here we're gonna have an if statement. So I'm just gonna scroll this up here. And if the layer type this time around is of an object group, and remember we have two layers of this type. The first one is the spawn points, but we did a different thing for it. We simply created this function to get the actual spawn points we're gonna use later. But for here, this is for the walls. So that's why we need not only to check the type of the layer, but we also need to check if the layer is of the layer name wall. I think it was walls. Yeah, that I don't remember actually. So let me just look it up. It was named boundaries, I think. Boundaries, because the walls are actually drawn. Boundaries is where the collisions the collisions are specified. And then for each of those boundaries, we're going to use a for loop const boundary of layer dot objects. Again, because it's a object grouped layer, we have the access to the objects property, which is an array of objects. And then we have a const. We're gonna use a const, and then we're gonna create something called a collidable. And then this is code we cannot write now because we need to create a collidable, which is basically a hitbox for those layers. So how are we going to deal with this? We're just going to need to create another entity. I'm going to create a new file. I'm going to call it collidable.js. And then in that entity that we're going to create, we're going to have to write some logic to make wait a minute. Okay, we're gonna use again the same pattern, but the whole point of the collidable is really to create boundaries and do the collision detection. So here, it's actually here where we're gonna write our own collision detection logic. So we need a function, make collidable. I'm gonna call it this way. And then here again, p, x, y coordinate, and then this time around we need also the width and the height of the collidable we want to make. We're going to return an object, and then we pass in the properties that we need to pass, and then here screen x and screen y are for reasons related to the camera. I've already explained this with the player logic, I think. And then we need to pass also the width and the height so it can be accessible, and we need a couple of methods. We need the prevent pass through from method here. So this is where the collision detection logic is going to happen and preventing that the collision occurs. So preventing from the object, the collidable, from going from passing it to another. And then the update function here, which is going to have a camera. We're going to pass in the camera. And then finally, the draw function. For now, let's leave it empty. This is useful for the debug mode. So yeah, we're going to call this later on. So let's write the logic for this, prevent pass-through from. And this is where the interesting part that is very transferable to any graphics library happens. Well, I think everything is mostly transferable, but this specifically, it took me a while to figure out. So first we need to detect if there is a collision. The way you do this mathematically without using any frameworks or libraries for collision is by using the simply math. So what we're gonna do is we want to check for 4 conditions and we want the reverse of those conditions. So let's start. So the concept is called rectangular collisions, and this is the more performant variant of the math required for this. There are plenty of good videos on the topic. I think Chris Courses did one where he explained how to implement rectangular collision. So this is a known topic. Now this variant I don't think he uses that because even though it's more performant, it's probably a bit harder to explain. But yeah, let's go with it. So what we need is we have access to the x and y coordinates of the collidable as well as its width and height. And since we're only dealing with squares and rectangles when it comes to collisions, this is enough. So the first condition we need to check for is if this dot x, that means this collidable x coordinate plus its width is inferior to entity.x. That means we don't have a collision on this condition, this axis. And then if we actually it doesn't necessarily mean that this dot x, yeah, probably a drawing might be helpful here. Let me just pull out Excalibur. All right, so I have Excalibur. So let's first do a drawing and then write the rest of the logic. So this, I'm gonna first copy and paste the code. So we have this, the font is not really legible. So let me just change this quickly. Let's use a code. Yeah, that's much better. I'm gonna zoom in. Okay, maybe like that. Okay, so let's have two squares. We have the first one. We have the second one. And the first one is going to be the collidable. Collidable. The second one is going to be the entity. Entity. Okay, so the first condition, and of course we need the to add a point here, which is going to be the x and y coordinate. Wait a minute. Yep, and this again, x and y coordinate. Okay, so what happens? So if this dot x plus its width, that means this value, this whole thing, is inferior to the entity dot x. That means if it's inferior, that means it should be behind. So yeah, this position basically. And if this dot x is superior to the entity dot x, or okay, it's an or. So or if the value of x, so either first case is either the entity is here or the entity is here. That means there is no collision when it's here and here. Or if this dot y plus this dot height, so the y coordinate plus the height is inferior to the entity height, that means the entity is here, there is no collision. And finally, the last condition is if the entity is below, then that means we have no collisions. So yeah, just to illustrate, when this is here, that corresponds to the first condition being true, or when this entity is here, that corresponds to the second condition being true, or when the entity is here, which corresponds to the third condition being true, and the fourth one is here when the entity is here. I mean, if all of these are true or one of them is true, that means this expression is going to be true. That means there is no collision. By using the bang sign here, we want the reverse of that. So the reverse of that means that any one of those four conditions, so none of those four conditions occur. That means that if this is false, and this is false, and this is false, and this is false, that means it's going to be false. And that means this is going to be true. That means there is a condition. There is a collision, because this expression within is only going to be true when there is no collision. When there is a collision, it's going to be false. But because we want to check collisions, we have the reverse of the operation. That means that the collision is true. So the reason it's reversed like that is it's less computationally expensive to calculate, because as soon as one of those conditions is true, we stop the calculation. We know that it's true because it's an or. Otherwise, you would have to use the reverse, where you check for the collision and you will have the and then your JavaScript is pretty much forced to check the first part of the condition, check the second part of the condition, check the third part of the condition, check the fourth part of the condition before determining whether or not there was a collision. But because this is an or, we only need to the first one. Okay, if the first one is true, then we don't bother, etc. So yeah, hope is it the case? Yeah, I think that's the case. I hope that was clear. So now I'm just gonna copy and paste it here instead of typing it out. It's gonna be faster. So this is how we determine when there is a collision. So here is the code. Feel free to pause. Okay, now that we know that there is a collision, we still need to write the logic to prevent the overlap. And this is what we're gonna write here. So when collision is true, we need to write some logic. And we're going to have two constant here. One called overlap x and overlap y. And this is necessary so we can figure out if the collision is occurring from the right or the left corner or from the top or the bottom. So we can know where to replace the colliding object so that it does not overlap. So overlap x here is we take the minimum between this x plus this width and entity x plus entity width, and then we subtract this by the maximum between this x and the entity.x position. And then for the overlap y, it's the same logic but with the height instead of the width. Once we have this, I would recommend that you draw this out using diagrams. I'm not going to do it now, but I think using a tool like Excalidraw, just draw the various operations, take some examples, and it's going to sink in hopefully. And then what we're going to do is I'm just going to copy again and paste it and go over it. We have another if statement within, and then if, so yeah, so the if statement is this way. So you could have written better code here. I realize you could have used a early return, but it would make a lot of this unneeded. But just for the sake of learning, you can see that things are clearly delimited. So if the overlap x is inferior to the overlap y, that means the collision is occurring from either the left or the right corner. And then if the this.x is inferior to entity.x, that means it's the right corner. That means we need to replace the entity that is colliding with the collidable to this.x plus its width, to the entity, to the collidable x plus the width. So really at the edge before the collision occurs. And then the same logic for the left corner. And in the case where overlap x is superior to overlap y, that means the collision is occurring from either the bottom or the top. To really differentiate this, we need to check if this.y is inferior to entity.y. And if it's the case, then simply we can replace the entity.y to the this.y plus this.height. So that means from the bottom and then from the top. So I think this is pretty straightforward. Again, if it's not clear to you, really just make a drawing, and I think like I did with collision, just do schematics, play with values, etc., and it should be clear. Now for the optimization, what I wanted to do is simply, as soon as you know, you would return early. So you would return here. That means you wouldn't need to have an else, and then you would need though a return statement here early, and then here you wouldn't need a an else at all. You could just do this, and then here you would return early within the first if, and then you wouldn't need this at all as well. And I think that would did I do something wrong? Okay. Whoops. Okay, we have the first if, it closes, and then we have a second if that we need to close here instead. And then we, of course, we need another bracket. Okay, so this code is, I think, much more clear what's happening. So as soon as we know that it's the right corner, then we return early. If we know that if it wasn't, then we go here, and then we know it's the left, then we return early. And if it was not right or left, we go here, and then if it's the bottom, we return early, and then the final case where we cannot return early, we don't need to return early. So I think that's a better structure. It's not in the original repo, so yeah, take note here. Okay, now for the update function, we're going to simply do the same as we did. We determine the screen X position by taking the position of the collidable and adding to it the X coordinate of the camera. The same thing we do for the Y coordinate. We do this Y plus the camera.y. And that's it. And then for the draw, here we're gonna need the debug mode. So let's actually make a debug mode. I think we did it. I don't remember actually. We didn't do it. So let's create a debug mode. So again, it's going to be in the entities folder. I'm gonna call it debug mode.js. And then what this does is it's a function, a simple function. I'm going to call it make debug mode. And then here it returns an object. And this object contains a boolean, that is whether or not the debug mode is going to be enabled. And then the second one is going to be a draw FPS counter. This is pretty useful to know how much FPS we have in our game. And then here we have an if statement. If this dot enabled is not true, then we return early. And then p dot push. This is so we have and then p dot pop. So we have code that is not pop. Sorry. And then p dot fill yellow. So we want to draw it in yellow. So this whatever p5 function I call between the push and pop will only be applicable to what's in there and not outside. So everything outside is going to be as if I never called those functions within the push and pop. And then the text size is going to be 24. And then p.text math, because by default p5 gives you the frame rate, but it's not an integer, it's a floating point, I think. Yeah, a floating point number. So it's a decimal number basically. And to not have to deal with that, I'm just gonna put a call the trunk function to truncate whatever comes next after the decimal. So we have an integer. And then once you have this, the frame rate as this first parameter of the text function in p5, we need to specify the coordinates of where to put it at x equal 10 and 20 y equal 20. And we don't need to put it relative to the camera because we don't want it to be affected by the camera at all. Okay, now we have this. We have another method needed, which is going to be a toggle that is going to allow us to turn on and off the debug mode, and it's going to be useful. We can just to toggle, you just take the current value of enabled, and since it's a boolean, you just need to put the bang sign on before to have the reverse of it. And then finally, we need to write the last method, which is to actually draw that hitbox. Draw hitbox, whoops, with lowercase. And then here it takes the p and hitbox, the actual hitbox, which is the collidable, I guess. And again, here we have a call to, we need to first check if the debug mode is enabled to decide whenever or not to draw it. If it's not, we just return early. And then here I'm just gonna make a call to pfill to fill a reddish color with an opacity of 63%. And then we're gonna draw the rectangle so that the rectangle does not hide the content of the sprites, but it looks a bit faded away so that we can still see that, hey, there are hitboxes here. So if I do hitbox like screen x to hitbox, it's important to use screen x and screen y and not x and y, because the hitbox we want them to be drawn relative to the camera. And then hitbox.width, hitbox.height, and that's basically it. All right, we have this, but you might have noticed that I did not make a call an export because we're just going to have one instance of this. So I'm just going to do export const debug mode equal, and then make a call to the debug mode here. You need to use the brackets, otherwise you're just giving the function with a different name that can be called. So that means that we only have one debug mode. And then if I go back here in the collidable logic in the map.js, not the collidable logic, and actually first in the collidable logic in the draw function, we need to make a call to the the debug mode. That means debug mode. I'm gonna import it, then call the draw hitbox, pass in the context, and just pass in this because this is the hitbox. The entity, the collidable itself is has all the properties we need. So by passing the this, we're passing the context so that the debug mode can have access to to screen X, screen Y, width, and height. Now you might want to not do that and pass in specific params. Feel free to do so, but I found this very convenient. All right, be careful to not forget to add a .js when importing stuff, because otherwise you get MIME type error. And then here we can go back to map.js, and in map.js, what's happening is we're gonna call the collidable, make collidable. We're gonna make a collidable for each tile. So make collidable, pass in the p, pass in the boundary.x, because each object in the object group in tile gives you the x and y coordinates. And then here we need to have this y, so the map y, and then we need to add the boundary.y, and then we need to add 32. That's very strange because I actually don't know why we need to add it 32, but if you don't do it, the way it works is that I think you also need to add here this dot x plus the boundary dot x, because it's all relative. We want the collidable to be relative to. Well, actually, thinking about it, why is this necessary? Because no, normally we shouldn't need it. So I'm gonna try to come back to this later on, because right now it's visually hard to see why, but I think I had to add 32, otherwise things would not be placed correctly, and I really don't know why. So now boundary.width, boundary.height, which is required for dot height, so that we can do the collision logic in the collidable itself. And then you just call the collidable dot prevent pass through from, and then inside here you specify the player. And remember, we passed the player to the draw function for this specific purpose. That means that really everything else is checking for collisions with the player. If it's not the player, we don't check collisions with really. And that's because it's good for now. But if you were to have a bigger project with more NPCs, you would have to add this logic. You would have to make sure that the collidables listen to collisions from any entity that is of a specific type, for example. That would be a way to go about it. And then collidable dot update should be called with the camera passed in, so that the collidable can know where to position itself. And then finally collidable dot draw. But this, again, it's only going to draw it if the debug mode is activated, because it just passes the call to the debug mode. All right, we have this. I think now it's time to use that. Use that in our world.js file, though. So world.js, where is it? It's here. So in world.js, we're gonna have to add a reference to the tile. So here you have the camera already. We have the player. We don't have the NPC yet, so we're gonna create a property, call it null for now for the NPC. We're gonna need call the map, create a map property, and then call make tiled map. Now that we have that, we're going to simply pass in the property. We want our map to be to start from the x coordinate of 100 and the y coordinate of minus 150. This is what looked good. You might need to play around with values. All right, so now we have this. It's time to, in our load function, we're gonna, before the player, it doesn't really matter, I think. Just call this map.load and then pass in the assets.trainer, tower, interior, map.png. And then for the second param, you're gonna need to pass, sorry, not call, maps.world.json. Once this is done, so the first path is for the tile set. The second path is for the tiled export that defines our map. And then here in the setup function, we're going to have to use the, so here, got this dot map dot prepare tiles. And then we're gonna get the spawn points, so const spawn points, but with the lowercase. And we're gonna use equal to this dot map dot get spawn points. And now once we have the spawn points, we can have a for loop that is going to iterate through each of those spawn points for a spawn point of spawn points. And then in there, we're going to have a switch statement that is going to check for the spawn point name. If you remember in tiled earlier on, we specified a name for both the player spawn point and the NPC spawn point. So we have two cases. If the spawn point name is the player, then we can just do this .player.x and then place the player according to the spawn point. And then for the player.y position, it's going to be here again, this .map.y plus somehow it's required spawn point.y and then plus 32. Then again, visually hard to explain right now unless we see the result and then we play and tweak them, and then you're gonna notice that somehow it seems necessary for some reason, and I'm just not sure why. All right, so here case.npc. Okay, so for the NPC, we same logic. If it's the NPC, and then we break, and then we use, of course, the default. Call it the default case. All right, we have everything we need, and I think let's look at the results. So I'm just gonna open up the project. Okay, we have an error already. This tile data is undefined in map.js. Map.js 1927. Map.js 1919. Where is 19? I think it's tile data. I forgot a D here. Now if I look at the result, refresh, this.npc is null. Yeah, that's because we haven't written the code for the NPC. So back to world.js, just not here at all. Here, just do nothing. Comment this out for now. And then if I press enter, I forgot to make all the draw calls in main.js. So let's go to main.js. Where is it? Main. All right. And then in here, instead of having world.update and world.draw, actually, let me just look it up in my original code base. So actually, it's just in the world.js. I need to replace the logic here. So instead of having, so for the update, we're gonna need to change anything. No, we don't need to change anything for now. But for the draw function, we're gonna need to change a couple of things. First of all, we need to add after the background 0 this dot map dot draw. Of course, we need to draw the map. This dot camera, and then this dot player. We need to pass those things as I explained earlier on. And then I'm gonna remove the rectangle. I think that's the only thing we need for now. And now let's look at the result. And then if I press enter, okay, this tile data again, 26, 27. I mistyped 26, 27 tile data. So, sorry if you've noticed those errors already. Come on, tiles pause is undefined. Okay, I made again another mistake. Where's tile pause? Which line? Map 50. Okay, 50. Where's 50? Okay, tile pause, not tiles pause. Oh, which is it? No. Tile pause. Was it tile pause in the original code base? Let me look it up. It was tiles pause. So this was a mistake on my end. So in prepare tiles, you need tiles pause, and in the calls here, tiles pause as well, because it's an array of tiles, so an array of positions that corresponds to tiles. So that's why it's more than just one tile. Okay, now we have it here, and then if I look at the result, tile number -1 is undefined. Okay, why is that? All right, so I was able to get it fixed. The reason was that in tiled I accidentally imported twice the same tile set, which meant that the numbers within the export were too big. So you would have layers here. So if I were to go to the world.json, I had like 497, etc., which were numbers that didn't exist because it was twice, like using twice the frame count. So to make just to reiterate, so in tiled, I accidentally imported twice the same assets. That means that instead of having like maybe a 800 by 55 tiles, I had twice that. And that means that when I use the get frames position in map.js here, get frames position, I specify 8 by 55. That means that the array of tiles pause was smaller than what the tile number could go through, because we had twice the numbers of assets, which meant that the tile numbering was all wrong. So now that this is fixed, yeah, so now it should be working. So let's I'm just gonna remove any console log if you were debugging as well. So here it is, and let's go back to the project, hit enter, and then you can see that we have a fully, actually not fully working. So if I were to, I haven't done anything for the debug mode yet, but anyway, there's a couple of things we need to change, but it's progress. So see you in the next part where we will fix all the issues and enable the debug mode, because now I have some collisions, but the collision seems to be delayed, it seems. So this is nice, this works nice, and okay, it seems really that the collisions are not right. I think that the issue here is probably instead of this.x, we could add 0 instead. And let's see if it changes anything. And yes, it does. So for some reason, I'll go over this hopefully in the next part of the tutorial. So now the collisions work properly. So now what I want to do is, since the current position, yeah, so we were able to fix the collision bug by setting this to 0 instead of this.x, but I'm not convinced of this solution because it makes no sense. You would want this x and this y because in this context it would be the map x and y origin, and since all tiles are relative to the map, then normally when we want to go back to the beginning of the map, we should do this dot x instead of this dot instead of 0. So let's figure this out. But before we can do that, let's go in main.js and try to enable the debug mode so we can clearly see the various collisions, various hitboxes. All right. So in the in the key pressed key event, yeah, and the key pressed function, I'm gonna just do a if statement, and then if the key event dot key. I think you could potentially transform this into a switch case if there's too many keys, but for now this is enough. And I'm gonna call the debug mode from the main file and call the toggle function. And then don't forget to import debug mode. Of course, if it didn't add the .js, that means you have to do it. You have to add the .js, otherwise you will have a MIME type error. Okay, now the other thing we need to do though is that in the draw function at the last line of it, we can call the debug mode.draw FPS counter, and we don't have to worry about when to draw or not, because the draw FPS counter will take care of looking if the debug mode is enabled or not, and then draw if it's the case. Okay, now I'm going to look at the result. So if I press shift, you can see the various collisions and it's working. Now what happens when I put the code back as it were? So if I go back to map.js and instead of 0 here, I would put this.x. What would happen? It wasn't really obvious initially. And you can see that everything is pushed a bit to the... Wait, there's a huge mismatch here. Okay, why is that? And let's figure this out. So if I go to the Collidables here, I've put the boundary x here. So if I add this dot x plus the boundary, what happens in this case? Okay, everything goes back to normal. Makes sense because we have the boundary x here is absolute. That means it's not related. So this is coming from tiled. And because it's coming from tiled, it's not relative to anything. It's really from the canvas position x would be here. And that's why we need to add the map, because everything is relative to the map. So this is specific to the boundaries. Now for here, where I had to do this dot xy, this boundary dot y, plus this dot y plus boundary dot y plus 32. What happens if I remove 32? Enter, shift. You can see that everything shifts above a bit. And this is something I just don't understand why. And it seems necessary to add at least a tile width. So here we could actually just, to make things clearer, this dot tile height for things to come back in place. This is something that was even in my previous tutorial in Kaboom.js. It seems that there is something going on, and I do not understand why why the value provided by tiled is not enough to just add it to the x value. So that's it. So here this dot x instead of 0, and it makes sense because it's relative to the map and not to the whole canvas. So that the x, if we were to put x equals 0, it would be to the whole canvas itself. Now I think we also had this same issue in the world.js file. I go to world.js, and in there I think I added this map x and then this point plus 32, and I think we need to also have this not this map dot x plus the spawn point to have the player being at the right position, because in the tiled we drew the spawn point here, so the character should appear here instead. And if when I removed this, it did not appear here. It appeared somewhere else, I think. Let's look at the result again. Yeah, it appeared here, which is not what we wanted. All right, now it makes more sense, but then again, the 32 that you have to add is kind of strange. I don't understand why you have to add a tile height to the overall Y position. This is something, like I said, from tile. Okay, I'm gonna also modify this comment to also add this map.x, just so I don't forget. Here, 32, it would have been nice to have the tile width. Fortunately, I think maybe the player have this information. If I go to the definition, do we have the width and height? No, we don't have. We have, oh, we have this property. We have this. So the player has it, so we can just use it instead of hard coding 32. We can just do this dot player dot tile height. And then here as well, this dot player dot tile height. All right. I think now let me look at the result, making sure. Ah, there's something strange. It shouldn't be here. It shouldn't be here. Ah, because the tile height here is not 32. It's 48 because it's relative to it's not the same tile height. So let's keep it to 32. That was a mistake on my part. I did not design things properly. Maybe in the map. I think in the map has it. The map. Oh, okay. At least the map has it, and it makes sense that it has it. So we can have this instead of hard coding 32. This dot map dot tile tile height. All right, and then this map tile height as well. And then let's actually work. Let's look at the result, and then once this is done, we can shift. Everything is properly placed. That's nice. The game is really taking shape, and that's really great. Now let's go and create the NPC. Write the logic for the NPC. So I'm just gonna pull this out from my original code base. Just to go faster, I'm probably going to just copy and paste chunks, and then we can easily continue. Actually, you know what? Let's go at it manually, and then so it's better so that you can clearly see how it progresses. Okay, so export function make NPC. It takes the context, x and y coordinate. Okay, so we are going to call the make character a function. Same thing as with actually, it doesn't make any sense to do this. We need to return an object and then spread it within make character.p. Okay, just to recap, we have the make NPC function that we just defined, and then we return an object, same pattern that we've been used to, and then we spread the make character call to have the attributes that we're gonna use. Same logic as the player, and then screen X and then screen Y for the camera, sprite X and sprite Y, same thing. Here in this case, it's the same as the player, I think. But if you were to use other sprites, you might need to do something else. And as I explained not earlier on, this was necessary because if you do shift, we haven't done this yet, but it's drawing the point here relative to the player. Actually, I just realized that we haven't defined for the player the hitbox yet, drawn it, so we should probably do that. So let's do it. Let's continue for the NPC, and then once for the NPC it's done, we can continue on. So here, you know what? I'm just gonna copy and paste just to go fast. So here, in the load function, same thing. We load the sprite. Then we have the prepare anims function, same thing as the player. We defined it here, but with different animations, just one basically. So it's a bit of a waste because we don't use the rest of the animations, but we still have to cut it 4x4. And yeah, but anyway, if you want to make the NPC move, feel free to do so. Then we have the setup function. This calls the prepares anims and set the animation to being idle down. And then the update function is basically, is it the same? We have the previous timer and then animation timer, and then I don't use the previous time, it seems. I think I don't use it at all. So it's not necessary. And then finally we have, actually not finally, but almost, we have the draw function, which takes in the camera and is going to basically position the player relative to the camera, and then we draw the debug mode. That's the thing I forgot to re-enable. So if we go back to player.js, in there I left as a comment, so this is not necessary at all. Doesn't do anything. That means, yep. That means here we can re-enable this so that we can draw in debug mode. Okay, and finally in make character. Do I have the previous time? Not necessary at all. So this is not necessary. And then if I go back to the NPC, we have here just, so it's the exact same logic. Here we can just draw this. We don't need to math round or anything. There's no bug because the sprite is just not moving. It's just not really moving. I think I did it for the, yeah. So the bug that is unexplained. It's in the player.js file, player.js, and then in there, it wasn't actually. It was in the map for the tiles that I had to round it because otherwise it would have a gap between tiles sometimes not, and this would only occur in the Edge browser that I've tested. For here I'm running the game on Firefox, so I don't have the issue. But if you were running this on Chrome, you probably would have had the issue. So feel free to test it out, remove it, etc. Okay. Now what I'm going to do is we have one thing left for the NPC, one bit of logic that is left to add. It's the last function, and this is a function that is new. It's not in the player, and it's for handling collisions. So handle collisions with entity, which is going to be the player that is going to be passed, and then a collision event. So the collision event is just I think it's just a function, a callback you pass. I should have called this collision callback or event. It's not that important, but anyway. First of all, if the entity is already frozen, that means the dialog has started, then we don't run the rest of the logic. Otherwise, we check the collision, and this was, of course, we had this in. Do I have this anywhere defined anywhere? I think I don't. So we'll have to define the check collision function because we had a specific collision logic in map.js. I just realized not map. Where is it? In Collidable. Yeah, it was in Collidable. If I go here in Collidable.js, we had this prevent pass through, which would compute the collision, etc. And in hindsight, I should have just created a utils function for it. But before we do any of that, let me just cover the rest of the code and then we'll do it. So yeah. So we check for the collision. This is something we're going to create. We pass in the current object and then the entity. And then if the collision is there, we prevent overlap. And this is another function that we're going to use. And then we freeze the entity. So that means we freeze the player because it's the one we're going to pass here. And then we run the collision events, and this is going to contain code that opens up the dialog box, etc., etc. Okay. So let's go to utils. And in utils, we're going to add two new functions. Let me just look it up. We're going to add the first one which is check collisions, like that. And basically the same logic I explained for the collidable. By the way, I think we're going to use this function instead of having the logic coded in the collidable. And then the other function is, again, the same thing. If I just copy and paste it, don't forget to add the E here. So this is something you've already wrote in the collidable code, but it's more generalized where you pass in both object A and object B. So yeah, same logic. And then even here, here I did the proper work of having early return statements to make things more clear. So now let's go to collidable and then replace this const collision with, let's comment this out for now. Let's replace this with const collision equal check collision. And then the object A is going to be this. That means the current, the collidable itself. And the object B is going to be the entity. And then here, again, we're going to remove that. Whoops, I removed the wrong thing. And in there, I'm going to call prevent overlap. And then this, and then entity as well. Okay, now that we have this done, let's make sure that the import is with a .js. It is. Let's go back to this, and we're going to have to import on the top. Import, so in npc.js, both check collision and prevent overlap. Okay, now let's look at the result for that. And there's an error. Debug mode is not defined. What do you mean? Player.js 87. Player.js. Wait a minute. So in player.js, I forgot to add the debug mode. So I commented it out, but forgot to add the import statement, debug mode. Okay, now if I do this, press enter, and I can shift, and then the debug, the collisions work. Nice. Looks great. 60 FPS. Okay, 58. It's fine. 50. It's between 58 and 60. So that's nice. And I think that's it. We have everything ready. And now we just need to place the NPC. To place the NPC, we're going to go back to, I think it is world.js. And in world.js, initially I put the NPC as null. We need to call make NPC. And then in there, we're going to have everything we need for the NPC. We need to specify a few things though. So we need to specify, we need first to pass the P. And then just let's put it at 0, 0, because anyway, it's going to be replaced. Those values doesn't serve us. This is just for testing purposes, where you were testing the players or the NPC before you were to put them in a map. And then here in the load function, we need to load the assets for the NPC. So let's call npc.load. And then once this is done, here we can comment this in. So we put the NPC x, etc. The x position is going to be spawn point, etc. Okay, and then we also need to call the setup function for the NPC. If you remember this.npc.setup, so if you remember in npc.js, the setup function would prepare the animations and then set the animation to being a specific one. And then where is handle collisions with though called? I think it's called in the draw function though. Okay. So for now, let's go back to the world.js, and then in the draw function, or it's in the update. Okay, first we need to call this.npc.update, so we have an updated position, etc. And then we need, I think it's in the draw call. I've put it. Maybe it would have been better to put this in the. I think this should be instead of the draw call, it should be in the update call. It doesn't matter really in p5.js because, like I said earlier on, there's only a draw function. There's no update functions. So our updating logic, we write it, we run it inside of the draw function. Same thing with using the HTML Canvas API. There's just a request animation frame, so there doesn't change anything, just for organizational purposes. So I'm going to call handle collisions with here. I'm going to pass in the player as the one we want to handle collisions with. And then here we pass the callback, which is the collision event. This is inspired a bit by Kaboom.js, how it does things when it comes to collisions. And then here I'm just going to console.log player collided with NPC. And then later on, we're going to do some logic for this. To open up, first we're going to have to create a dialog box, the component for it, then do the logic for it, etc., etc. And then we're going to initiate dialog, write the logic to display dialog. Once this is done, blink the screen, and then set initiate the battle. And then from now on, it's just the battle. All of the the turn-based battle, the Pokémon, etc., the movements, etc. Okay, so now that we have this, and I think we're ready to test things out. Do we have everything we need? I'm just checking for this. I think we do. All right, let's look at the result. Okay, get frame pause is not defined in npc.js 17.7. So npc.js 17.7 is here. Get frame pause is here. We forgot to import it from the utils. And then let's do this. All right, shift collisions work, but the character isn't there. Why is that? Did I forgot to call the draw method in world.js? I think that's it. I have the npc.update, but I don't have the this.npc.draw, and then pass in the camera, of course. I think things should be working. Debug mode is not defined in npc. Forgot again to import the debug mode. Let's do it here. Import debug mode, like I forgot for the player. And now everything should be draw tile is not defined in npc. Of course, I need to also forgot to import draw tile from the utils, and then it should work. Okay, now you can see our character is here and it is remaining fixed. That's really nice. So if I go and talk, you see player collided with NPC, and then I freeze, because if you remember in the logic for the NPC, when we collide with him, when it handles the collision with the player, it will freeze the player, because we want to display some text and we don't want the player to be able to move around when they are in a dialogue. All right, that sounds good. We're ready to continue and write the logic for the dialog box, so actually dialogue. And then once this is done, we make the screen blink, and once this is done, we're ready to battle. All right, so now let's work on the dialogue. So the goal of this is to create a component, the dialogue logic, a dialog box that can not only display dialogue, but also will later display choices for for moves, etc. Because I don't have the assets for the actual overlay here in this project. So in the entities folder, create a new file. This file is going to be called dialogbox.js. And then here again, export. So it's the same pattern all along. Export function make dialog box pxy. Return, and then whoops. Okay, this looks weird. Okay, x y, and then here we're gonna have a sprite ref, which we're gonna hold a reference to the sprite for the dialog box. I had a current time. This, I think it's going to be necessary because we're gonna have to implement dialog scrolling. That means letters appearing one after the other, and we're gonna need the timer. So we need both a property for the current time, current time, and a property for the previous time. And then finally, actually not finally, we need to have line chars, which initially is null, but contains an array of all the characters of the line you want to display, the line of text you want to display. And line contains the content of the line as a string. So we're gonna basically split whatever text you want to pass to display into a line chars, which is going to be an array of characters, and then we're gonna gradually add it to this line property, which is a string. So the phrase is the sentence is going to be constructed gradually. Okay, now we have an on-complete call, actually an is visible property to know whenever or not to display the dialog box, and then an on-complete callback we want to run, and for now it's null, but this is something that we're gonna pass later on if we want something to happen after the dialog, a specific piece of dialog is over. And then we're gonna have an onIsComplete boolean to know if the text is actually fully displayed and the dialog is complete. And that's it. So, and then for the methods, we have the load method used to load the sprite, etc. This is a really logic that I'm not gonna spend any more time on this. We did it so many times. So this sprite ref p load image pass to the image, and the image here for the dialog box is overlay message.png. And then the next thing we're gonna need is two methods, actually three methods. So first one is called setVisibility, is to basically set whether or not the dialog box should be visible. This is useful because once we finish a dialog, we want to hide it, and yeah, that's the reasoning for it. We also want a method that allows us to display the text immediately, so all the content all at once. This is for when you have to select the Pokemon attack and we want to display the choice 1, 2, 3, and 4 immediately. We don't have to gradually wait for each character to be displayed. And this is just done by replacing the content of the line property with the content that is passed by this function, and then putting the isComplete boolean to true. Finally, well, actually not finally, but almost done, we have the display text. Display text is a function that is what we do initially. So that means it takes the content, it takes an onComplete callback, and then splits the content into an array of characters, and then if the onComplete it sets the isComplete to false, and then only when the onComplete is passed that we set the onComplete callback to be the onComplete passed by the user of this function, and then otherwise we just put it to null, and that's going to come handy because here we're just setting to display the text, and then the update and draw logic of the dialog box takes care of doing the actual displaying. And then once the displaying is done, since we passed the onComplete, it's going to call it, and yeah, this is how we have a functioning system. And then we also need a clear text method to just wipe out everything that was displayed. And finally, the update loop. So the update loop is very important, and I want to really get this right. So I'm just going to copy and paste it as well. So the update function first, if it's not visible, if the dialog box is not visible, there's no bother continuing. And then here it's where it's important to have the current time. And I just realized that we don't use the previous time at all, so we can remove the property. So here we have this current time. We need to add in the p.delta time, as I explained. This is to make our game frame rate independent and based on time. But here is really just for the timing. And then here we calculate the duration per frame. And here, this is a good speed. As I explained earlier on, this value is the frames per second. So we want 60 frames per second. And then we want to know how many time each frame will have, considering that 1 second is 1000 milliseconds, and this is 60. So It's give us a value of the value in milliseconds of how long should we display a given frame. And the reason I'm talking in frame from our game, and this also allows us to know when to display the next character, when to add the next character. And here is the same logic where if that current time is superior to the duration per frame, that means superior or equal, that means that it's time to show the next frame basically. And here we do our logic where we modify, we decrease the current time by the duration per frame. I explained why instead of setting it to 0 earlier on. And then here we just take the next character of our line of char, and you can do this very quickly very easily with a shift method, which will give you the first element of an array and pop it out. I think that's the what the function does. Let me just I usually when I hover it gives me a definition, but I think it's this. It gives you the first element, and then it pops out the first element, and then gives you but it modifies the array. Pop is the same thing, but for the end of the array, so removing the last element instead of the first. And then here, if this is complete, so the dialog is complete, we just return early. This is for the update loop. And then if the next character, if we don't have a next character, that means this is undefined or null, and it is not complete, then we set the complete to being true, and then we run a callback if the callback is defined. That was passed optionally by the user here. If they don't pass anything, that means this is not defined, and then we just set null. You could have decided not to do this line, but just when it's intentional, it's better to use null. When it's unintentional, this is where undefined should appear. Basically, when you structure your code base, this is how I've been taught how to use null versus undefined. Okay, now that we have this, we have everything we need, and then we add to the line the next character that we just had here. And then for the draw function, we have this. So here, I'm going to paste it here. And then only run the logic for the draw function if the dialog box is visible. And then it takes the sprite reference for the dialog box by using the p.image. And this time around, we don't need to have anything fancy. We don't need to use the draw tile function that I created that wraps around the p.image with the form with various params. Here, we just need to pass in the reference and the x and y coordinate because it's a single image. And then here we specify the p-fill to be black because our text, we want it to be black. The text size, we want it to be 24. And then ptext is the p5 method to draw text. And we just pass in the text we want to draw, which is the line, which is the string basically. And then here the position relative to the position of the dialog box that we defined in this.x and this.y. This is what looked good, those values. Feel free to play around. Okay. To check that everything works, let's go to the world.js file. World.js file. And then where I initially placed a console.log statement, we're instead going to call the function. So this is what I'm going to do. I'm going to, first, we also need a reference to the dialog box, of course. So at the top of the world definition, maybe after the map, let's put make, let's have a property called make dialog, or just dialog box, and let's call make dialog box. It should import it manually, automatically, and then p0, and then 0, that would be the coordinates 0 by 200. And because by the way, the dialog box is not affected by the camera, that's why we're using direct values like that. We don't have any logic in our dialog box logic in the draw function to account for the camera because we don't want the dialog box to be affected by the camera. And this is basically how you would want to draw every UI element, not relative to the camera. So then in world.js, in the update here in the callback, I'm going to call this dialog box and then display text. And then in display text, I'm just gonna copy this, what I had, just to have exactly the same thing. I see that you need training. Let's battle. This /n is used to create a new line. So that means this is going to display it's going to be displayed in a new line. And then remember that display text from dialog box has a second param, which we can pass in a callback, and it's going to be an async one because we're going to use await in a moment. So just this for proper formatting. And then inside here, I'm going to create an await, a new promise. I'm going to explain in a moment with a resolve. Let me just write it out and I'm going to explain it. And a set timeout that will call that resolve function that is passed. And then after having waited for 1000 milliseconds. And then just to put this in context, I'm just going to have this dot dialog box set visibility to being false. And outside of it, though, we need to actually set the visibility after the player has collided. So this dialog box set visibility to being true. So just to explain what is happening, when the player collides with the NPC, this runs. When this runs, we run this. This will run immediately. I mean, we give this, but this will run only when the text is going to be fully displayed. That means this, what comes after, runs immediately and makes the text box visible. Now, once the text has been fully displayed, this will run and will create a new promise. So a promise is a mechanism to deal with asynchronous code. That means that if you have code that can be executed while something else, or intermittently while something else is going on. So in practice, what happens with async code, think of the fetch function or the set timeout function. If you call the set timeout function without any async await or without wrapping it into a promise here, what happens is that this will run and then immediately the next thing will run, even though this is still running. So there are a few functions like that in JS. The fetch one is another one where if you call the fetch function on line 48, for example, without any await or anything like that, your code execution will continue on the next line while the fetching is being dealt with until it's done, and then but the code is still continuing. So when you want things to be ordered in a sequential manner, so you don't want to move on until the set timeout function is finished, then a way to do this is to create a promise. And what you do this by creating a new promise, and then the promise has two tools usually, a function called resolve that you can pass in, or a function called reject, and you can pass both. Here we're just interested in the resolve function. So the promise constructor will pass the resolve function to the function that is passed within the constructor. That's a bit hard to understand. So, so the promise allows you to create a promise. So the promise constructor allows you to create a promise. A promise is a mechanism to basically monitor the state of a asynchronous function or operation. It can give you it gives you a status, basically. It is pending or fulfilled. And once the function within that runs, which is this one, is finished, you have the responsibility to determine when to call it. So here, this code, what it does is the resolve function here is provided by the promise constructor. There's also the reject function that you could have taken here, but I did not because it's not necessary here. The resolve function is then passed to the function that we passed to the constructor. And here I decide to do my logic here. I call the setTimeout, which the setTimeout function in JavaScript takes two params. It takes a function that is going to be called after a certain amount of time has elapsed in the second param, defined by the second param. So here, once 1000 milliseconds, that means 1 second has elapsed, it will call the resolve function. Once the resolve function is called, this resolve function passed by the promise notifies the promise that it is done, that it is fulfilled. And the await keyword here, what it does, it basically tells the function, the async function, to not proceed on with the rest of the code unless the promise is resolved. And that's how I get code that is executed sequentially. So this is how I get a timer that the rest, it's the equivalent to the Python sleep call, where you wait a certain amount of time before proceeding on with what comes next. Hope the explanation was clear. Feel free to watch it again and again to really let it sink. And there's plenty of resources online that explains this probably better than me. All right. So now that we have this, we actually need to, in our draw function, to remember to call this.dialogBox.draw. We also need to call this in the update function, this.dialogBox.update. Okay, so we have both of these. Do we need the update? Yep, I think we need it. Yep. Okay, now let's look at the result. So both in world.js, don't forget the update and draw functions of the dialog box. This is very important. Did we call it in the setup? I think, do we have a setup function for the dialog box? Let me look. We don't need one. Okay, in that case, it's fine. Okay, let's look at the result. So if I refresh, press enter, move along, and then I'm gonna try to collide, and then we have a an error. Okay, E is null. What? In P5, E is null. Okay, that gives me nothing to work with. So from P5, entity dialog box, JS 58, line 58 of the dialog box. P, do we have P? Yeah, we have P. Did we, in world.js, did we pass the P tag? Yep, we did. In that case, I don't know what went wrong. Okay, that's strange. Okay, maybe if we, maybe the update, in the update. So what was the line? The line was here, 58. If I go to line 58, we have this dot sprite ref, this x and this y. Did I really call the load? I did not. Okay, in world.js, you have to call this dialog box load to, of course, load the assets initially. So now it should work. Press enter. Gonna move. I see that you need training. Let's battle. Okay, it works, but the positioning is a bit strange. So this is something I need to fix. Let me just, I see that you need training. Let's battle. Okay, that's very strange. Why it's doing this? Did I do it properly? Okay, it's not 200, it's 280 for the dialog box. I press enter. And I see that you need training. Let's battle. And now we need to work on the logic to make everything blink. And once everything blinks, the battle really starts. And then it's time for the battle logic. So we're almost there. Just the battle is going to take a bit of time, but hopefully there's not much left to the tutorial. By the way, if you're enjoying the content, feel free to subscribe so I can produce more content like this and know that it's interesting. Also, feel free to watch my other tutorials. And yeah, that's that. All right, so now let's make the screen blink. By doing this, we're going to really initiate the battle, and then we'll write the logic to switch to the next scene. So here in our world.js file, what I'm going to do is we're going to need the basically almost the same properties that we needed earlier on in the menu when we wanted to make it the text fade in and fade out. So I could have maybe used the same logic and code, but you know what? Let's do it independently so that yeah, it's simpler this way. But you could feel free to refactor. So the properties we're gonna need is make screen flash, which initially is false. We're gonna need an alpha value to control the opacity of the screen, the whole screen. We're gonna need a blink back boolean, which again, like in the menu, what it does is it's basically it allows you to how do I say this? It controls when we need to fade in or fade out. And then easing, which is going to be 3. So basically the frequency of change, basically. All right, so now here we can, I think, go directly into the update function. And then right below the dialog box update, we can write the same logic that we wrote initially for the menu. Feel free to create a reusable function and use for both the menu and this part, the world.js, this logic, because it's exactly the same. So just to recap, here we determine whether or not it's time to fade in or fade out. Here we determine, yeah, and this is where we change the value of the opacity. Now, yep. So if you wanted to change this, maybe you would have to pass in the property in your function, or maybe create a yeah, I think it should work if you just pass the property in your function as a param. But then again, it can be quite confusing. You need to be careful when you need to really be clear about if your function is modifying params, the value of params. That means it is passed by reference instead of by value. So in JavaScript, I think variables and a bunch of stuff are passed by value. However, I think arrays and objects are passed by reference. That means if you modify an object within a function that you passed in as a param, it's going to modify it for real. And as for the array, I think you can, if you use the methods like pop or push or stuff like that, it will actually modify the array itself, because those structures are passed by reference and not by value. A language like Golang is much clearer on this, where you have the star notation, the pointer notation, when you want to use you want to pass a variable by reference instead of value. So this is something that you need to be careful when dealing with JavaScript. But yeah, that's just a parenthesis on the topic. All right, so in the draw function, basically, I think it's just we want to make the whole screen flash, and this is where it's going to be a bit different than in the menu. So this is the code we're going to need to add in the draw function of the world.js, is that here, this makes screen flash if it's true. So here, here we don't put it to true here. The way it's going to work is after the dialog, within the async. I think I'm just gonna put it either here, yep, here, right before changing the. I'm not sure if I should put it before or after. Let's work on that later. But just wanted to clarify here that we don't need to use the tint method from p5, because we can just fill the whole screen with the black color and then make so basically the fill method here selects a color. So here black RGB 000, that means it's going to be black with an alpha value that depends on how opaque we want it to be. And then we create a rectangle of the size of the screen. That starts at the coordinate 0, 0 in the canvas. And that's how we get the illusion of making everything flash, by just changing the opacity of that rectangle that is put on top of everything. So this is how we achieve that effect. Now for the here, when we handle the dialogue, etc. So we have this. I see that you need training. Let's battle. Then once this dialogue is complete, we have a promise that runs, which is basically a wait 1,000 milliseconds. And in fact, maybe we should just create a utils in utils.js. This is not in the original code base, but I think this would be a nice addition. So I'm just gonna call it export async function. Async function, and then we could call it wait. I'm not sure if it's a reserved keyword though. But we could call it wait and then pass in the milliseconds you want to wait as at, and then we can just return a where's the, if I go back to the world.js, not JSON, world.js, I go back to world.js. So here we can just copy that. Come on. If I copy that line and then I go back to utils, actually this doesn't have to be. Does it have to be async here? You know, we could. Okay, let's return a new promise, and then here instead of 1,000 milliseconds, we would have ms for that stands for it for this, and then in the world.js, I would simply remove this and type in await, wait, and then 1,000 milliseconds, and then here did it import it from the utils? Nope. So now we could import wait from utils.js. Where is it? Where is it? Here. Now let's see if everything works all right. Press enter. Let's talk to the, I see that you need training, and then it disappears. Is it like that? I think it is. The reason I'm hesitating is because I don't remember how it was before. So if I'm just gonna put an await here though, to be like it was previously, it's not necessary. I don't think it's necessary. Let's just bump up the time that we wait to 3,000 milliseconds just to test things out. Now hit enter. I see that you need training, and then it waits, and it waits, and it's over. All right. Yep, it seems to be working, and it makes our code much more concise. Await, wait. Okay, maybe we should call it sleep. Sleep should be to be like in Python, and also I think wait might be something already defined in JavaScript. I'm just not sure, and so let's do sleep, and it looks better than await, wait. So here, let's go with sleep. So it's gonna sleep for 1,000 milliseconds, and then we can continue. So what do we need next? After having made the visibility false, we want to make the screen flash. So we're gonna set this to being true. After this is done, we're gonna await sleep again. So the screen should start flashing, and we're gonna let it flash for a while before continuing on. So let's wait another 1,000 millisecond, and then set the this make screen flash back to false. And then here we can use the setScene function that we initially passed through here. Yep. And we can switch to the battle scene. And this is going to be the last part of the project. So once this is done, let's test it out and see if it works. So if I go here, I talk to the old man, and then there's a flash, and then there's an error. Set scene is not a function. World.js 5921. Okay, why is this an error? Probably because in main.js, maybe in the setup, or here in make world, I did not pass the set scene function that we're gonna pass. We don't call that function, we just pass the definition so that we can call it later on inside. Just in case you didn't know that. The difference between this and with the parentheses. If you pass with the parentheses, it calls it immediately, while if you do this only, it's going to you can call it when you want. Okay, now let's look at the result. If I go here, I move shift, just making sure that debug mode works. I see that you need training, let's battle, and then it switch. But because we didn't do the switching yet, we didn't clear the screen, etc., we're gonna do that now. So that means we have finished with the world scene. You learned a bunch of concepts. You learned a bunch of concepts that would be useful in other games. How to use tiled, how to implement rectangular collisions, how to implement a camera system. So that all these concepts, you can reuse that in any other project that is top down. And now it's time for the battle. So here, it's time to create the battle scene. We haven't created it yet. So go to the scenes folder, create a new file, call it battle.js. So battle.js will have the following content. We will first start with I would say a bunch of states we want, because the way the battle is going to be carried out is that there are various states during the battle. The first one is going to be the default state, and this is just to have like a kind of an enum. That means we can easily find the state we want without having to write strings where we could easily make mistakes if we try to copy the states. So it might not be clear right now, but you'll see in its usage that it's going to be much more straightforward. So we have the intro NPC state. Intro, those are states I just invented. Depending on your game, you're gonna come up with various other states. And the reason you need states is because you need to be able to do draw different things in different states of the battle. So the intro.npc is when the NPC presents himself, wants to battle, and then goes out and throws their Pokemon. And then we also have the intro NPC Pokemon. So when the Pokemon of the NPC is drawn or introduces themselves in the battle. Once this is done, we have the intro of the player Pokemon, which is intro player Pokemon. And then, you know what, just to be quick, I'm just going to copy the other states. So here are they. So player turn when it's the turn of the player. Player attack when the player have decided an attack and now it's time to carry it out. NPC turn, which is going to be just the attack immediately. And then battle end when the battle ends, and winner declared when the winner is declared. All right. Now what we're going to need to do is to create our scene. And to do this, we're just going to have an export function make battle. So the exact same pattern we've been using all along. Return an object, a bunch of properties. The first one is going to be the actual dialog box. It's very important to have it because this is where we're going to display all the text related to the battle. We need to pass in the P and this coordinate. This is what looked good. And here, don't forget to add a .js in the import statement. Now, the current state is going to be another property that's needed. And we're just going to set it to default by default. And then for the NPC, we're going to create an object and hold a bunch of important values for the NPC. Same thing for the NPC Pokemon. I'm just going to leave them empty now. And then we'll have also the same thing for the player Pokemon. And then finally, but I think that's it. Yeah, I think that's it. And now we're going to have a bunch of methods. We need a draw data box method. So here I did not follow a good convention because in hitbox I use lowercase, but here I use capital. So yeah, just make sure to use exactly the same, even though it's inconsistent. Sorry, I did not realize the inconsistency. Sorry. So this is the function. We're gonna fill it out later. We also are going to have to create an async function for dealing damage. So I'm just gonna write the definition for it. Whoops. Target Pokemon, attacking Pokemon, and then empty. And then for now, later on, I'm gonna explain why it's async, etc. And then we need a load function. We need a setup function. Actually, I should have put the setup before the load, but let's just keep it like this because usually, oh, never mind, never mind. The load function is called before the setup for loading the assets. And then after the setup, it's the update function. And finally, after the update function, it's the draw function. Okay, and I think that's we need the on key pressed with the key event. This is important to allow the player to select various attacks. Okay, we have all of our functions. What we're going to do now is go to main.js and then set things up there, so that we don't find ourselves with a bunch of errors when we finish writing the code for the Pokemon the battle, basically. Okay, now here in the right below the where we define the world, we're gonna define the battle as well and call the make battle function, pass in the p tag. Once this is done, in the preload, we're gonna also do a battle.load to load the various assets. For now, there's nothing written in the load function, but we're gonna come to that later. And then the setup, yep, we have the setup. We also need to set up the battle. So battle.setup. We didn't need this for the menu because there was nothing to really set up. And then here in the to-do that I left here, this is where we're gonna call the battle.update and then battle.draw, and that's it. And then finally here for the events, if the current scene in the key released or key pressed, yeah, here, if the current scene is equal to the battle, then we could run the battle on key pressed and pass in the key event. And that's basically it. Yep. Now that we're done with this, we can go back to battle.js and continue on. So in battle.js, I think I'm gonna write two helper functions. Let me just look. Okay, so let's set up the various attributes we need for both the NPC, the Pokemon, NPC player Pokemon, the player Pokemon, etc. So instead of writing the various properties within the object here, let's create a function that I'm gonna call. Let's do this for the Pokemon because there's a lot of shared properties. So make Pokemon. Here we're just gonna pass in the name, the X position, the final X. So this is an attribute that when the Pokemon introduces themselves, then when the battle starts and the Pokemon introduces themselves in the battlefield, they are initially hidden and then they slide in the battlefield. So the final X represents the final position they land when it's actually time to battle. And we're going to make sure that there is a gradual translation, or I guess movement, towards the initial X to the final X, so that we have this sliding effect. And then we have the Y position, which doesn't change. the max HP that the Pokemon can have, the various attacks that they can use. We're also going to need to pass the data box. So data box is the health bar, basically. So it's called data box because this is what the assets had. So here, if I go to data box thin and then data box thin foe, so those are the data box. So it's the whole thing, not just the HP. So in battle.js, I'm gonna just close this to organize stuff, and then here. So we're gonna return a bunch of properties, the name, the final x, the y, the sprite ref, which is null, that we're gonna fill in later on, the max HP, and then we're gonna set another property called HP2 initially being the max HP. We're gonna set up the attacks as being the attacks, which is, it's going to be an array of moves, which are in an array of objects. An is a selected attack. So for the selected attack, initially null, that is going to be used in this turn. An is fainted property to know whether or not the player, the Pokemon has fainted. And finally, the data box itself, which is going to be here. The data box is going to be an object itself, and we're also going to write a function for making it because there is a bunch of shared logic between the data box needed for the player Pokemon versus the data box needed for the NPC Pokemon. The only difference is they are drawn differently, and yep, and they also need different coordinates, but yeah, they're mostly similar. So x and y are the two attributes we need, so where to position the data box. We need also name x and name y, which are just the where we're going to draw the name of the Pokemon on the data box. So it's relative to the data box, but it's important because it has an offset. We need to offset things and really place it somewhere in the data box because it's not there by default in the asset, in the PNG file. We then need to also position the health bar. So we're going to have a health bar X and the health bar Y. So going to position them within the data box. And that's it. So now if I open up here, I do return, and then X, I do Y. I then have a property called name offset, which, like I said, it's for the name. It's just the reason I'm calling it name offset like this is because that's a better name. It's a much better name. All right, so here I'm using the name offset attribute because it describes better what name X and name Y are. I could have technically done this here, but I could have changed this, but you know what? Let's keep it this way. Let's keep it this way, otherwise the rest of the code base will not work. So then I have the health bar offset as well, which is again X is going to be just health bar X. Y is going to be health bar Y. And then a sprite ref to that specific data box, which is just a reference to the sprite we're going to load for that data box, which is different depending on if you're the NPC or if you're the Pokemon, the player Pokemon. And then finally, the max health bar length in pixels, which is 96. This is what figure fitted here. Between this and this point, it's 96 pixels. I just did this through experimentation. And then the health bar length, which is also 96. The difference between those two properties is that the first one is the maximum it can be, and this is going to be the property we're going to update to know how to draw the bar as it depletes. Okay, now if I go back to the code, let's for the NPC there isn't much, you know, here in this scene. So just an X position, and we're just gonna put Y, not Y, X 350, Y 20, and a sprite ref. initially null. Now for the NPC Pokemon, this is where calling the make Pokemon function is going to be handy. And then here I'm going to call it Venusaur. I'm going to use Venusaur. X position of 600. And what, I'm just going to copy and paste this to go fast. So let's do this like that. So you see 600, 310. So the initial X is this, and then it goes backward to 310 because it will slide in from the right side of the screen. And then 20 pixels here for the Y coordinate. The coordinate of 20, not 20 pixels. And then 100 is the maximum HP. You can know which param is which here. And then the attacks here is the object, so tackle, and then the power for it. I did not have time to deal with the the typing. That would have added too much complexity for a first project in p5.js, and I would never finish it because I was not familiar with p5, and I just learned it on the fly in this project. Now, make data box is useful here because it's very concise compared to having to rewrite this and add it here. So that's great. And that's basically it. I think that's it. Is it? Yep. And now for the player Pokemon, we're gonna do the exact same thing, just different values. So feel free to copy and paste this as well. By the way, if you're too tired to type it, just go to the GitHub repo and copy the code. So here it is. Make Pokemon for the player Pokemon. This time it's Blastoise and a couple of different attacks. And now for the draw data box, it's all the logic to draw the data box. So here you just pass in the Pokemon that you want to draw the data box from. For. And then this is how it is done. So let's go at it gradually. So the first call is to draw the actual sprite itself. So by doing Pokemon.databox.sprite.ref, you have access to it. By the way, right now we haven't loaded the sprite, so you should not call this before having called the load function. But the way we structured our code makes it that we don't call we don't risk of calling this before the load, because anyway this is called within the draw call, which is called much later. Okay, so we have the Pokemon data box X and Pokemon data box Y, which is the positioning. And then right below we have the name of the Pokemon we want to draw. And we just do Pokemon.name to have its name. So remember the property, the first one, which was the name property. And then, wait a minute, do we have it? Okay, yeah, we have it. And then here we draw the name according to an offset. So here we take the position of the data box and then we add the X offset for the name. Same thing for Y. And then here is the logic to draw the data, the actual health bar. So I'm going to paste it and I'm going to explain it. So we have a push and pop call because we want the change in colors here, the fill, to only affect this region within. So the health bar, nothing else. Because by default, if you call fill and do not make this call within a push and pop, it's going to apply to everything that is drawn next. So here we select the angle mode to be in degrees. So this is a P5 method to select the P degrees. So instead of using radians, the reason we're doing this is because we want to rotate 360 degrees the health bar, because when we reduce the health bar, we want it to be reduced from the right corner instead of the left corner. And since things are drawn from the left by default, if we were to not rotate it, then the health bar would deplete from the wrong side. And then we specify that we want to draw a rectangle with no strokes, so we want to draw without strokes. And then here we have 3 if statements. So depending on the health bar, so if the Pokemon data box.health bar length, that means the actual health bar, is 50, is superior to 50, then we draw it we fill the rectangle gonna draw here with green, so RGB, so it's the only value with a value superior to 0. If the health bar length is inferior to 50, that means we want it to be yellow, and to get yellow we have a bit of a majority of red and a bit of green. And then the last if statement is that if it's inferior to 20, that means we are in critical condition, and we just use the red value. So just the health bar will be drawn red. And the p.rect here is for drawing the health bar. Here again, the positioning is according to health bar offset. Here same thing for the y. And then here it's the length, which will update later on with the deal damage function that we're gonna write later. And then the width is 6 because it is what looked good. This is 6 pixels roughly. And then we pop because we don't want the fill instruction to affect what is drawn next. Alright, so now it's time for the actual damage dealing. So for damage dealing, again, I'm going to copy the code and I'm just going to explain it. Now here, instead of using this promise, we created a new sleep function. And we're just going to wait 1000 milliseconds. So, okay, so let's start from the beginning. So we have, in this function, we have a target Pokemon and an attacking Pokemon. The target Pokemon is the one who will receive damage. The attacking Pokemon is the one who will do the attacking. So what we do is, by having those two objects, we can directly modify the HP by subtracting the HP of the by subtracting to the target Pokemon HP the attacking Pokemon selected attack power. So later on we're going to see how, instead of being null for now, the selected attack property, where is it? Here, is going to hold the attack that the player has chosen amongst the array of objects of attacks here. So one of them is going to go into the selected attack, be copied to the selected attack attribute property, and we're going to get the specific power value and subtract that to the HP. Now, if the target Pokemon HP is superior to 0, it's time to calculate the new health bar length. And the way we're going to calculate this is by taking the target Pokemon HP and multiply it by the max health bar length, and then we divide this by the max HP. So this is a way to have a correspondence between the HP and the actual length of the health bar. It's a rule of 3, I guess it's the name in English. I don't know. It's a very known mathematical relationship. Well, if you have like if 50 is for on 100, then how 20 is on what, or something like that. It's I think it's called the rule of Troy or 3 or something like that. Anyway, and then we return early because we computed the value and we don't need to do anything else. Now, if it's not the case, that means the Pokemon is dead. The target Pokemon is fainted. Sorry, not dead. Then we directly put the health bar to being of length 0. We set the is fainted attribute property to true. We wait 1000 milliseconds before going to the next state, which is the states.battleEnd. And this, by the way, is how you go from one state to another. And here I just do states.battleEnd, and it's going to give me this string. This is just a way for me to not make an error while typing out battleEnd, the string itself. I could have done this, but yeah, you risk making a typo error, and it becomes harder. While with this method, it just suggests you what you should choose, and the risk of making an error is really low. Okay, now the reason this is important, that to wait 100 milliseconds, because while we wait, we are drawing stuff still, and then when we go to the current state, then we change. So it's to give enough time for whatever needs to happen. The sprite of the fainted Pokemon needs to collapse down to happen before. Otherwise, if we just end the battle, then the sprite will not move, and yeah, the game will not work. All right, it's time to now do the load function. So for the load function, it's going to be a bunch of calls at first for loading stuff. So here it is, loading various type of images. So the first one is the battle background image. Here's the path, NPC sprite ref, NPC Pokemon ref, player Pokemon sprite ref, the data box for the Pokemon, the player Pokemon, the data box for the NPC Pokemon. Once we have all of our assets, don't forget also to load the dialog box because we have imported it, but we haven't called the load function. Okay, now we have in the setup function, this is where we're gonna initially set up a bunch of things. It's going to be a complicated mess. This part, I should have probably written the code in a much better way, but yeah, it is what it is. So if I just copy and then I will go gradually with each line. And then here instead of, let me just remove this and use await sleep 2000 milliseconds. Did I make him? Okay, right. And then here the same thing. Await dot sleep. I think it's 1000 milliseconds. And then here the same thing. Await dot sleep 1000 milliseconds. And then finally await sleep 1000 milliseconds. Okay, how does this code work? Because it looks like it's almost entering a callback hell here. So, yeah, what happens is that we first display the first text, mark the gentleman wants to battle. Once this is done, we have our callback. We wait 2000 milliseconds, and then we enter the intro NPC state by changing the current state. We clear the text in the dialog box. Then we display some other text, and then he sends out, and then we're using a template string. We just get the name of the NPC Pokemon, and we display that. So he sends out a Venusaur. And then once this is displayed, we have the callback for this display text call, which once this is completed, we change the state to the intro NPC Pokemon, because now that we have called this, we need to show we need to make the NPC Pokemon slide in the battle. So once we are in this state, we sleep for 1000 milliseconds. That's because during that time, in the draw call, we're going to have the logic to draw the NPC Pokemon sliding into battle. Then once this is done, we clear the text and we display some other text and go the name of the player Pokemon. And after this is displayed, we change the state to being the intro player Pokemon. And we sleep for 1000 milliseconds. We display, we clear the text, and then we display what will the player Pokemon do. And then we wait 100 milliseconds, and then we switch to the player turn. Now this is not ideal code, but I just wanted to get done with the project. I could have potentially thought of a better structure, but I'm glad it stopped here. So the rest of the code is pretty much not that deep in terms of callbacks. So it's the biggest level, the deepest level here of callbacks. So 1, 2, 3, and 4 callbacks. All right. Now that we have this, it's time to deal with the update function. Did I do everything correct in the setup? Did I do? Yeah. Okay. So now it's time for the update function. Here again, I'm just going to copy and go over each line. Here we go. So the first if statement is all the logic that happens when the state is the intro NPC. What happens is that we increment the NPC X position by 0.5 multiplied by p delta time. This is for it to be frame rate independent. This is for the NPC sprite to slide into battle. And then the second if statement is for when the state is the intro NPC Pokemon and the NPC Pokemon is still superior to their final X position because they're entering from the right side. That means that their initial X position is higher than the final X. So as long as this is the case, we're gonna subtract 0.5 to the X position of the NPC Pokemon so that it gradually slides into battle. Here, the P delta time is again for making sure that our game is frame rate independent. And then within it, as soon as we notice that the NPC Pokemon data box X is inferior or equal to 0, so as long as we notice that the data box is inferior and equal to 0, we'll add to the data box for the NPC Pokemon 0.5, and this is the reverse, because while the Venusaur, the Pokemon, is sliding from the right, we want the data box for that Pokemon to slide in from the left. This is how it happens in Pokemon games. So now we have finished another state. So I'm just gonna collapse every state we finished talking about. Now this state is when it's time for the player Pokemon to introduce themselves. And as long as the player Pokemon X is inferior to, this time is inferior because by default the player Pokemon X position is inferior to its final X because it is in the left side of the screen, and we wanted to bring it to slide in from the right, from the left to the right instead of from the right to the left for the Venusaur. And this is the same logic basically. And here instead we don't really care that much. We just subtract the data box X. So we don't care about like we did in the previous state of it to be inferior or equal to 0. Actually, I have my doubts. I think this is not necessary. I think the reason I did this is to prevent, because when it reaches 0 and you add 0.5 to it, it's going to, wait a minute, as long as the NPC, yeah, I think try it out without this and tell me if it works. I think it's the reason I did this is that if it's inferior to 0 or something weird happens, but I think that might not be the case. We might actually test it out later on. Okay, so here same logic. The data box is going to be introduced from the right side while the player Pokemon is introduced from the left side. That's why it's a minus, and here again p delta time. When the player Pokemon is fainted though, we will increase the Y position by 0.8. Those values, 0.8, 0%, is just what looked good. You can try different values. This is to make the Pokemon sprite collapse down. Because remember, in the canvas, if you increase the value of Y, you go down instead of up. And then finally, here, if the NPC Pokemon is fainted though, we basically do the same thing actually, but with the NPC Pokemon's position. And finally, we need to call the dialog box update call. All right, now the last part and the biggest function in the code is really the draw function. So here again, I'm gonna copy it over and talk over it line by line. Okay, so let's start from the beginning. We clear the background, everything that was drawn. We clear everything that was drawn, not just the background. We clear everything that was drawn previously. We set the background to black. We draw the battle background at the origin, 0, 0. We draw the various Pokemon sprites. We draw the data box. This is where we call draw data box. We do the same for the player Pokemon. This was for the NPC Pokemon. We draw the data box for the player Pokemon. This is what it was for the NPC Pokemon. If the state is the default state or the intro state, then we will draw the NPC sprite because they are introducing themselves. After that, they will slide back out and we Don't need to make the draw call anymore. And then here this if statement, if the current state is the player turn and the player doesn't have a selected attack defined, so it's null, then we will display immediately the various choices the player has, which is done by a string, a template string, where we just take each choices. So this player Pokemon attacks index 0, the name, 2, name, or 2, 4, and etc. So the reason it's 1 and 3 is because the way it's going to be laid out is 1 and 3 are on one line and 2 and 4 are on the next. And here, remember, this is to make a new line. So you do the same here and same here. Okay, now for for this next if statement though, is when it's the player turn, they have selected an attack, and the player Pokemon has not yet attacked, and the player Pokemon is not fainted, because if it's fainted, they shouldn't be able to attack. Then we will clear the text box. We will display this text, Pokemon name, so the name of the Pokemon used, and then the selected attack name. And the selection of the attack is going to be done in the later on in the on key press, when they press the key. So if I go back here, so it's not done here. Here is just to display the attack. So now, once this text is displayed, we have the incomplete. So once we just do the logic for dealing damage, which will wait some time or something. I think yeah, it will sleep a while, do the damage calculation, so that we can move on to the next state. And then wait a minute, where I was here. Yep. And then here I'm just gonna replace this call to a sleep. It's gonna be more concise and less clutter. Wait, it was 1000? Oh, yeah, it was 1000. So if this current state is not equal to the battle end, so as long as the current state is not to the battle end, then we wait 1000 milliseconds, we clear the text, and then we move on to the next state. Because in the deal damage function, if the Pokemon faints, the state will become battle end. And by having this if statement, we make sure that the battle hasn't ended, so we can give the turn back to the NPC. And then outside of it, so while we were displaying the text here, right after, we have the is attacking being true, because while this is displaying, that means the attack is ongoing. So yeah. And then we have this, and then again, I'm just gonna refactor this with sleep 1000 milliseconds. Okay, so here what's the logic is now, if the current state is the NPC turn, and the NPC is not fainted, that means the NPC can attack, and then we can just randomly select an attack for the NPC Pokemon by looking at the attack array and doing this bit of math to select a random element from that attacks array for that Pokemon NPC Pokemon. So by doing math floor, math random times the length of the array, you get an element that is within the attacks array length, and it's random. Actually pseudo-random, because we use the random function, but I don't want to delve into true randomness. Anyway, here we clear the text, and then we display the foes, the name of the Pokemon used, the name of the selected attack. And then once this is displayed, we have our callback that we define. We deal the damage, and as long as the state doesn't end, the battle ends. As long as the battle hasn't ended during the deal damage phase, we sleep for 1000 milliseconds. We set the selected attack back to null. We set the is attacking back to false, which we did. Which we didn't do here though. Current state, I think it comes later. Okay. Now that this is done, so I've covered this if statement and this one. Now, if the battle ends, so we are in the battle ends. If it was the NPC Pokemon that fainted, then we will display this message. We don't need a callback, and we set the current state to winner declared. And if, on the contrary, it's the player Pokemon that has fainted, we will display the name of the Pokemon, the player Pokemon that fainted and they lost, basically, and we declare the winner. And here it's a rectangle for the because the battle background sprite doesn't cover everything, so this is just a black rectangle that covers the whole background, basically. No, actually, no. Because the dialog box doesn't cover the whole bottom portion of the game, of the battle, then we need to create a rectangle so that when the Pokemon slide downward, they don't, it doesn't look weird. And then finally, we call the dialog box draw. Now, one thing is, where is the player Pokemon attack, selected attack back, set back to null? I think it was here. Okay, let's continue on. And then if it doesn't work, then I'll know where to look for it. Okay, now in the onKey press event, in the onKey press thing, we're gonna need an if statement. And this is where the logic for selecting the player Pokemon attack. Basically, as long as the state is the player turn, we can check for if the key pressed by the player is either 1, 2, 3, or 4. And depending on which it is pressed, we can just select the attack, basically, and set it as the selected attack. All right, I think that should be it. Let's look at the result, and if everything works out. If it doesn't, then we'll know where to look for. Hopefully. I see that you need training. Let's battle. Mark the gentleman wants to battle. And then we don't. And then, okay. Use tackle. Use takedown. Hydro pump. I saw a bug, and yeah, you lost. Okay, now let's redo this, because the way the character slided is kind of strange. It slided wrong. Okay, that's very strange. All right, so the reason it didn't work properly and the gentleman NPC did not appear is because I made a mistake here. It's not current state, it's current state. Yeah, that's sorry. Now if I refresh and play the game again, everything should work fine. And I see that you need training. Let's battle. And then the gentleman wants to battle. He slides away. Venusaur is here. Blastoise is here. What we'll do, and then I press Hydro Pump, and then Hydro Pump again, and I win. So this is where the game ends, and yep, that's it. That's how we make a game in p5.js. A simple prototype, yes, but this is how you do it, with a bunch of collisions, etc. And then I'm sure you could expand on it. Now, there's one thing I want to really confirm, like finish off on, is you see at one point in the update function, where is it? Here it is. I have not the draw function, sorry. I have this statement where if the player Pokemon selected attack is not null, then what happens if I remove this statement? Will the game work fine or not? Because I don't see anywhere else where I use it, so that's why I'm wondering, did I add this by accident? So Mark the gentleman wants to battle. He sent out Venusaur, go Blastoise, and then what would Blastoise do? And then you have, and then it doesn't go away. So it doesn't go away. That means it's necessary. Why it's necessary? Because I don't see where we changed that. The current state. So we deal the damage, and in deal damage, there is no way where we set back the attack to null. So that's strange. Okay, let me check if we don't selected attack equal, and then Okay. We set right after dealing the damage here. I missed it. So I'm gonna recognize that the code for the battle is a bit messy. I was hoping to make something clearer, but I wanted to work on other projects, so maybe in the future I'm gonna refactor this. But for now it works. So here is where the selected attack is set back to null for the player Pokemon. It's after having displayed the foes used, and I just didn't see it initially. So we need to have this condition to display this, because once the attack is selected, we want this to go away because we're gonna display some other stuff. All right. Thanks for watching for this first tutorial in using p5.js. I make JavaScript tutorials mostly on games at the moment, using the Kaboom.js library, which is a very easy to use library for making games. However, I think p5.js is kind of nice, and I might use it for other projects, other tutorials. For example, maybe a pixel art editor, how to make that, or how to make a portfolio as a top-down 2D game. So a developer portfolio, I have seen some of them made, and we could very easily do that with p5.js. Since it's not a real game, it's just a gamified app, I guess, where we need collisions, we need a camera, but that's it. So we can reuse a lot of the knowledge we learned here. So anyway, if you enjoyed the content, the courses, the tutorials, feel free to subscribe, share the content around. It helps a lot the channel grow. And thanks for watching. Bye.